Hello there and welcome to Life Beyond Scene, where curiosity settles in for the evening and the quiet corners of science unfold at a gentle pace. This is a place for slow thinking, long stories, and the kind of questions that seem simple at first, but often lead somewhere surprising. Tonight's journey takes us to a cold and powerful moment in North American history, a storm so intense that people who witnessed it struggled to describe what they had seen. It was later called the White Hurricane, a storm that roared across the Great Lakes in November of 1913, bringing winds that rivaled ocean hurricanes, snow that erased entire towns overnight, and waves so large that steel ships simply vanished beneath them. The lakes themselves seemed to harden into something colder and stranger, and in many places it felt as if winter had arrived all at once without warning. Before we begin, I have a small question for you. Where are you listening from tonight? Perhaps you're somewhere warm, somewhere quiet, maybe with a cup of tea nearby or the soft hum of evening outside your window. And what time is it there right now? A storm like the one we're about to explore unfolded across several days, yet each person who experienced it lived through the hours in their own small moment of time. Someone might have looked out a window at a calm lake in the morning, only to see the world transformed by afternoon. Someone else may have been standing on the deck of a ship when the first gust arrived, still unaware of what was building across the horizon. If you find these quiet explorations soothing or interesting, feel free to leave a like on the video or subscribe to the channel. It helps this little corner of calm reach others who enjoy wandering through science, history, and strange events at a slower pace. Now then, let's settle in and begin, because on a calm November evening more than a century ago, the surface of the Great Lakes looked almost peaceful. The air was cool, but not unusual, the kind of cold that people living near the lakes were already used to. Autumn had been slowly fading for weeks. Leaves had fallen, docks were quieter than they had been during summer, and most people assumed winter would arrive gradually as it always did. What they did not yet know was that one of the most violent storms in the history of the Great Lakes was already beginning to assemble. The Great Lakes are often described as inland seas, and that description is not an exaggeration. When people picture lakes, they often imagine something small enough to see across, perhaps with a quiet shoreline and still water. The Great Lakes are nothing like that. Taken together, they form the largest group of freshwater lakes on Earth by surface area. Lake Superior alone is so vast that standing on one shore you cannot see the other side. The horizon stretches out like the ocean. Waves can rise several meters high. Storms can build across hundreds of kilometers of open water. Ships have traveled these waters for centuries, carrying iron ore, coal, timber, grain, and many other goods between the industrial cities that grew around the lakes. By the early 20th century, the lakes were crowded with freighters and passenger ships, moving constantly between ports in the United States and Canada. Detroit, Cleveland, Chicago, Buffalo, and many other cities depended on this network of shipping routes. During the warmer months, the lakes were busy with traffic, and even as autumn approached, many vessels continued to operate, trying to finish as many journeys as possible before ice closed the shipping season. November on the Great Lakes is always a complicated month. Summer warmth is long gone, but winter does not yet have full control. Cold air masses begin moving south from Canada, while relatively warmer air sometimes drifts up from the south. When these different air systems collide above the open water of the lakes, storms can develop quickly. The lakes themselves hold heat from the summer months, and that stored warmth can feed weather systems in unpredictable ways. Sailors who worked the lakes understood this pattern well. They had a saying that circulated among crews for generations. The phrase was simple and direct: November gales. Everyone who worked the lakes knew what that meant. November storms had a reputation for arriving suddenly and bringing dangerous winds. Even experienced captains treated the season with caution. Still, storms were part of life on the lakes. Ships were built to handle rough water. Crews were used to strong winds and heavy waves. A difficult storm might delay a journey or push a vessel off course. but most sailors believed they could handle whatever the lakes decided to throw at them. The storm that began forming in early November of 1913 would challenge that confidence in ways nobody expected. Weather forecasting in 1913 looked very different from what we know today. Modern meteorologists rely on satellites, radar networks, computer models, and constant streams of atmospheric data. In the early 20th century, forecasts depended mostly on surface observations collected from weather stations. These reports were transmitted by telegraph, and meteorologists used them to piece together a rough picture of developing weather systems. This method worked reasonably well for ordinary storms, but it had limitations. Large weather patterns could move faster than the reporting network could track them. Important details about upper-level winds and atmospheric structure were simply invisible to the instruments available at the time. During the first days of November 1913, a series of low-pressure systems began moving across the central United States and Canada. Each one carried strong winds and cold air. On their own, these systems might have passed through the region without much notice. But something unusual began to happen as they approached the Great Lakes. Instead of continuing eastward and weakening, the systems started interacting with one another. Cold air from the north collided with warmer air from the south. Pressure gradients intensified. Winds strengthened. What had started as separate weather disturbances gradually began merging into a single, much larger system. On the morning of November the 7th, conditions across the lake still appeared manageable. Winds were noticeable but not extreme. Many ships continued their scheduled routes. Cargo vessels loaded with iron ore left ports along Lake Superior and Lake Michigan. Passenger steamers carried travellers between cities along the shores. Weather warnings were issued in some locations. Storm flags were raised at certain ports, signalling rough conditions ahead. But the scale of the storm forming over the region was not yet fully understood. Through the afternoon, the wind began to rise. At first it came in long, steady gusts sweeping across the open water. Sailors noticed the change quickly. The surface of the lake shifted from small ripples to rolling waves. Clouds thickened across the sky, dark and heavy. The air temperature began dropping as colder air pushed south. On Lake Huron, several large freighters continued their routes despite the growing wind. Turning back was not always an easy decision. Ships carried schedules and cargo contracts. Reaching the next port quickly could mean avoiding the risk of ice later in the season. Captains had spent years learning how to read the lakes. Many of them believed they still had time to reach shelter before conditions worsened. But the atmosphere above the lakes was now organising itself into something much more violent. By the evening of November 7th, the pressure system driving the storm had deepened dramatically. The difference between high-pressure areas and the growing low-pressure centre became extreme. Air rushed inward toward the storm with enormous force, creating winds that soon exceeded 70 miles per hour in some places. For comparison, those speeds fall within the range of hurricane-strength winds. The term white hurricane would only appear later, after people tried to describe what they had witnessed. At the time, sailors simply felt the wind rising higher and higher, pushing waves across the lakes in massive rolling lines. The situation became even more dangerous as temperatures continued falling. Snow began to mix with rain, carried sideways by the wind. Visibility dropped. Harbours that had seemed reachable hours earlier began disappearing behind walls of blowing snow. Ships that were already far from shore had little choice but to continue fighting the storm. On land, people living near the lake started noticing the sudden shift. In towns along Michigan, Ontario, and Ohio, the wind rattled buildings and swept through streets. Waves crashed against breakwaters and docks. Snow piled against doors and windows. Telegraph lines swayed under the pressure of the wind. Still, few people understood the full scale of what had begun. Across the Great Lakes region, multiple weather systems had now merged into one enormous storm spinning over the lakes. The pressure at its centre dropped lower and lower. Wind speeds climbed even higher. Snow intensified. Night fell across the lakes and the storm continued to strengthen. Out on the water, captains struggled to keep their vessels pointed into the waves. If a ship turned sideways to the wind even briefly, the force of the water could roll it dangerously or send waves crashing across the deck. Engines strained against the wind, crews worked in freezing conditions, ropes stiffening with ice as spray from the waves coated everything in a thin, hard layer. The lakes, which had appeared calm only a day earlier, now looked more like an ocean during a severe storm. Some captains attempted to reach the nearest harbour. Others decided the safest option was to ride out the storm in open water, where they had room to manoeuvre. Each decision carried its own risks. Snow continued falling through the night, driven sideways by the wind. In many areas, visibility dropped to almost nothing. Ships that might normally have seen each other miles away could barely detect lights through the storm. Back on land, telegraph operators struggled to keep communication lines active. Weather stations continued sending reports, but the pattern forming across the region was unlike anything most forecasters had seen. By the early hours of November 8th, the storm had grown into a powerful cyclone centred directly over the Great Lakes. And this was only the beginning of what the storm would become. Morning eventually arrived over the Great Lakes, although in many places the word morning felt a little misleading. The sky was heavy with thick clouds, the air was sharp and cold, and the water stretching across the horizon looked darker than usual. Along the shorelines of several states and provinces, people stepped outside and noticed that the wind had not settled during the night. In fact, it seemed stronger than before. Waves rolled toward the shore in long, powerful lines, slamming against docks and stone breakwaters with steady force. To understand why the storm that was forming would become so destructive, it helps to pause for a moment and look at the lakes themselves. The Great Lakes are often introduced in geography lessons as 5 large bodies of water sitting between the United States and Canada. On paper, they are labelled simply Superior, Michigan, Huron, Erie, and Ontario. But when people actually see them for the first time, many are surprised by how enormous they are. Standing on the shore of Lake Superior or Lake Michigan can feel very similar to standing on the coast of the ocean. The water stretches outward until it disappears beyond the curve of the earth. Waves rise and fall across the surface. The horizon seems endless. If you watch carefully, you might notice ships far away that look like tiny shapes floating against the sky, slowly moving across the line where water meets air. Together, these 5 lakes contain about 20% of the world's surface fresh water. That is a staggering amount of water sitting in the middle of a continent. If all that water were gathered into a single body, it would cover an area larger than many countries. Lake Superior alone holds more water than the other 4 lakes combined. The size of these lakes means they behave very differently from smaller inland lakes. A small lake might respond quickly to changes in wind or temperature. Waves may rise and fall, but they remain limited by the lake's short distance from one shore to the other. The Great Lakes, however, allow wind to travel across vast stretches of open water. Meteorologists call this distance the fetch, which simply means how far the wind can move across water without interruption. When the fetch is long, the wind has more time to transfer energy into the water. That energy builds waves that grow taller and stronger the longer the wind continues. On the Great Lakes, the fetch can stretch hundreds of kilometres depending on the direction of the wind. This means that when powerful storms arrive, waves can become enormous. Lake Superior, the largest of the 5, is especially known for this. It stretches roughly 560 kilometres from west to east and reaches depths of more than 400 metres in some places. During major storms, waves on Superior can exceed 9 metres in height. Those waves roll through the water like moving hills carrying enormous force. Lake Michigan sits directly south of Lake Superior and is connected to Lake Huron through the narrow Straits of Mackinac. Michigan is the only Great Lake entirely within the United States, bordered by the states of Michigan, Wisconsin, Illinois, and Indiana. Chicago, one of the largest cities in North America, sits along its southwestern shoreline. Lake Huron, which lies east of Michigan, is another massive body of water filled with countless islands and long shorelines. It is home to Georgian Bay. a large bay filled with rocky islands that sailors sometimes describe as a maze of channels and narrow passages. Lake Erie is the shallowest of the 5 lakes, but it can still produce powerful storms. Because of its shallow depth, Erie reacts quickly to wind and temperature changes. Waves there can become chaotic and steep, rising quickly during strong storms. Finally, Lake Ontario sits at the eastern end of the system. It receives water flowing from the other lakes through the Niagara River, which famously forms Niagara Falls before the water continues into Ontario and eventually out to the Atlantic Ocean through the St. Lawrence River. All 5 lakes are connected through rivers and channels, forming a giant freshwater system that drains toward the ocean. Water entering Lake Superior eventually makes its way through the entire chain, travelling hundreds of kilometres before reaching the sea. For centuries, these lakes have served as natural highways across the centre of North America. Long before modern cargo ships appeared, indigenous communities travelled the lakes using canoes built from wood and bark. These communities understood the lakes deeply. They knew which winds were dangerous, which currents were strong, and which shorelines offered safe passage during storms. Later, European explorers arrived and began mapping the lakes. French voyageurs carried furs and goods along these waters during the fur trade era. Over time, settlements grew along the shores, and the lakes gradually became centres of trade and transportation. By the late 19th and early 20th centuries, the Great Lakes had transformed into one of the busiest shipping networks in the world. Large freighters moved iron ore from mines near Lake Superior to steel mills in cities like Detroit and Cleveland. Grain travelled from farms across the Midwest to ports where it could be shipped to distant markets. Coal, lumber, machinery, and countless other goods moved across the lakes throughout the shipping season. These ships were impressive machines for their time. Many were made of steel and measured more than 150 metres long. Their engines pushed them steadily across the water, even during rough weather. Crews worked day and night loading cargo, navigating narrow channels, and guiding vessels through busy shipping lanes. Yet despite their size and strength, these ships still faced a powerful opponent whenever storms arrived. Unlike ocean storms, which can sometimes be tracked for days as they move across large areas of open water, storms on the Great Lakes can develop rapidly. The lakes sit in a region where different air masses frequently collide. Cold air flows south from Canada. Warm air sometimes drifts north from the Gulf of Mexico. When these air masses meet, they create unstable atmospheric conditions. During autumn, this contrast becomes especially dramatic. The lakes remain relatively warm after absorbing heat throughout the summer months. At the same time, cold Arctic air begins pushing southward more often as winter approaches. When cold air moves over the warmer lake water, energy transfers into the atmosphere. Storm systems can intensify quickly under these conditions. Another factor is the geography surrounding the lakes. The region includes wide plains, forests, and open terrain that allow wind systems to travel long distances with little resistance. When strong pressure differences develop in the atmosphere, winds can accelerate dramatically as they sweep across the lakes. Sailors who worked these waters often developed a healthy respect for these forces. Many captains kept careful watch on the sky and water, looking for signs that conditions might change. They watched cloud shapes, wind direction, and wave patterns. A shift in the colour of the sky or the smell of the air could sometimes signal that a storm was approaching. Even so, storms could still catch ships off guard. One of the most challenging aspects of the Great Lakes is that storms can build waves that reflect off shorelines and interact with other waves. This can produce chaotic water conditions where waves approach from multiple directions. A ship might climb one wave only to meet another crashing across its side. Water could pour over the deck, freezing in the cold air and adding dangerous weight. And freezing water is another serious challenge on the lakes during late autumn and early winter. When waves crash over a ship during freezing temperatures, the spray can quickly turn to ice. That ice begins coating railings, cables, and equipment. Over time, the ice can grow thick and heavy. The added weight raises the ship's centre of gravity, making it less stable. Crews must often break the ice away manually using tools to keep the vessel balanced. If ice accumulates too quickly, the ship can become dangerously top-heavy. This combination of powerful winds, towering waves, and freezing spray creates some of the harshest conditions sailors can face outside of polar regions. During ordinary storms, experienced crews could often manage these challenges. Ships would slow down, adjust their course, and wait for the storm to pass. But when a storm becomes strong enough, even large freighters can struggle. And that is exactly what was beginning to happen during the early days of November 1913. The storm forming across the Great Lakes was drawing energy from multiple sources. Cold Arctic air continued moving south. Warmer air pushed northward beneath it. Pressure differences increased. Winds accelerated across the open water. Because the lakes are so large and interconnected, the storm was able to move across them while continuing to gather strength. On Lake Superior, waves were already rising higher than normal. Ships reported strong winds and heavy seas. On Lake Michigan and Lake Huron, conditions were beginning to deteriorate as well. Captains received warnings through wireless telegraph messages and signal flags raised at certain ports. Still, many ships continued travelling. Shipping seasons were always a race against time. Once winter ice formed across the lakes, navigation would become impossible until spring. Crews and companies tried to complete as many deliveries as possible before the season ended. Turning back meant delays and financial losses, so ships pressed forward into the wind. Along the shorelines, residents watched the water with growing concern. Waves rolled toward beaches and docks in steady lines. In some areas, the wind carried spray far inland, coating trees and buildings with a thin layer of ice. The lakes looked restless, shifting under the pressure of the storm building above them. What made the situation particularly dangerous was that the storm was not simply passing across the region. Instead, the pressure system was deepening and reorganizing directly over the lakes themselves. This meant that the winds would not quickly move on. They would continue strengthening. As the storm tightened its circulation, winds began blowing from multiple directions across different parts of the lakes. This created confused wave patterns where water surged unpredictably. Ships attempting to maintain a steady course found themselves climbing steep waves only to plunge into deep troughs seconds later. Communication between vessels also became more difficult. Snow and heavy cloud cover reduced visibility. Wireless messages were sometimes interrupted by atmospheric interference. Some captains began reconsidering their routes. But by the time the true scale of the storm became clear, many ships were already deep within the vast inland seas of the Great Lakes, and the winds were still rising. November has always been a complicated month along the shores of the Great Lakes. It sits directly between two very different seasons, and the lakes feel that change more strongly than almost anywhere else in North America. By the time November arrives, the warmth of summer has faded. Trees along the shorelines have already dropped most of their leaves. The air carries a steady chill that hints at the colder months ahead. Yet the lakes themselves still hold on to a surprising amount of heat. All summer long, sunlight pours into the surface of the water. Because water stores heat very efficiently, the lakes warm slowly during the summer months and then release that heat slowly once autumn arrives. By early November, the surrounding land has cooled much faster than the water. Forests, fields, and towns across the region may already feel cold enough for frost most mornings, but the lakes are still holding on to a leftover memory of summer. That difference in temperature between water and land becomes extremely important when cold air masses begin moving south from Canada. Cold air is dense and heavy. As it spreads across the continent in late autumn, it moves over the relatively warm surfaces of the Great Lakes. When this happens, heat and moisture rise from the water into the colder air above. This transfer of heat adds energy to the atmosphere. The result is unstable air that encourages cloud formation, strong winds, and rapidly developing storms. Meteorologists sometimes describe this as the lakes feeding the atmosphere. When the conditions line up correctly, storms can grow surprisingly quickly over the Great Lakes. A calm morning can shift into strong winds by afternoon. Rain may change into heavy snow in only a few hours. Sailors who worked the lakes often spoke about how quickly the weather could turn, and many of them developed a careful habit of watching the horizon and the sky. People who lived along the lakes understood this pattern as well. Fishermen, harbour workers, lighthouse keepers, and dock crews had all learned that November required attention. The month had a reputation for storms strong enough to reshape entire shorelines. Long before modern meteorology existed, sailors had already noticed the pattern. Over generations, they developed a phrase that passed from one crew to another: the gales of November. The phrase was simple, but it carried a lot of meaning. When someone mentioned the November gales, they were referring to a period of the year when storms tended to arrive suddenly and with serious strength. Ships could be caught far from shore. Waves could rise faster than crews expected. Cold temperatures made every task more difficult. Despite that reputation, shipping on the lakes continued through most of November. The reason was practical. The Great Lakes were one of the most important transportation systems for the growing industrial economy of the United States and Canada. Massive quantities of iron ore moved south from mines near Lake Superior to steel mills in places like Detroit, Cleveland, and Chicago. Grain from farms across the Midwest travelled through the lakes to reach eastern markets. Coal, timber, and machinery moved in the opposite direction. Stopping this movement too early in the season would disrupt the entire system. Shipping companies therefore pushed their vessels to keep operating as long as possible before winter ice shut the lakes down completely. Each year there was a quiet race against the calendar. Crews and captains tried to complete one more voyage, deliver one more load of cargo, reach port before the ice began forming. By early November in 1913, that race was already underway. Ports along the lakes were busy with activity. Freighters moved between cities carrying heavy loads of iron ore and coal. Dock workers loaded grain into large cargo holds. Tugboats guided vessels through narrow channels and into harbours. Along the waterfronts of cities like Detroit, Buffalo, and Cleveland, people were used to seeing large ships slowly gliding across the water. On some days, the lakes appeared calm and almost peaceful. A light wind might ripple the surface of the water. Gulls circled above docks, waiting for scraps from fishermen. The sky could appear wide and clear, with long views across the horizon. But November had a way of changing that calm very quickly. One of the first signs of approaching trouble often came from the wind. A shift in direction could signal that a new weather system was moving into the region. Experienced sailors noticed these shifts immediately. Wind that had been blowing steadily from one direction might suddenly turn colder and stronger. The air itself sometimes felt different, sharper against the skin. Clouds were another clue. During stable weather, clouds above the lakes might appear thin and scattered, but when large weather systems approached, thick layers of grey cloud would begin spreading across the sky. These clouds could stretch for hundreds of kilometres, forming an almost continuous blanket overhead. Rain often followed soon after. Rain in November along the lakes can be cold and steady. It drifts across the water in long curtains that blur the horizon. Visibility drops as distant ships fade into the grey atmosphere. Waves become rougher as the wind strengthens. If temperatures continue falling, that rain can change into snow. Snow on the lakes behaves differently from snow that falls over land. Wind sweeping across the open water can carry snow horizontally through the air. Instead of drifting gently downward, the snow flies sideways in thick sheets. Visibility can drop to only a few meters. Landmarks disappear. The surface of the lake becomes difficult to see as waves and snow blend together in the storm. During the first week of November 1913, these early signs were already beginning to appear. Weather stations across the central United States reported falling air pressure. Low-pressure systems are important because they often signal the formation of storms. When pressure drops in the atmosphere, air begins moving inward toward the centre of the system. That movement creates wind. At the same time, colder air was descending from the north. In ordinary situations, a single storm might pass through the region and then move eastward toward the Atlantic Ocean. Conditions might remain rough for a day or two before calming again. But the pattern forming in early November was different. Instead of a single storm, multiple systems began developing one after another across the central part of the continent. These systems moved toward the Great Lakes region and started interacting with each other. One low-pressure area deepened while another approached behind it. Cold air pushed southward, while slightly warmer air continued flowing north from the lower United States. Meteorologists today would recognize this setup as a strong atmospheric clash between different air masses. In 1913, the tools available to forecasters were limited. Weather observations came from stations spread across large distances. Reports travelled by telegraph lines that sometimes took hours to reach forecasting offices. The overall pattern developing across the continent was difficult to see clearly in real time. Even so, warnings were issued. Storm signals were raised at various ports around the Great Lakes. These signals used large flags to communicate weather warnings to ships in harbour. A square red flag with a black centre indicated a storm warning. Two flags raised together meant even stronger winds were expected. Sailors who saw those signals understood their meaning. But warnings alone did not always stop ships from leaving port. Captains often had to balance caution with the demands of their schedules. If every storm warning prevented travel, many ships would remain idle for weeks. Experienced captains believed they could navigate through rough weather if necessary. Most storms that crossed the lakes, after all, eventually passed. By November 7th, winds across several lakes had begun strengthening noticeably. On Lake Superior, waves rolled across the water in broad lines that rose higher with each passing hour. The sky was heavy with thick clouds, and the air temperature continued dropping. Several large freighters were already underway, carrying iron ore toward ports farther south. On Lake Michigan and Lake Huron, conditions were also deteriorating. Winds pushed whitecaps across the surface of the water. Spray drifted through the air near shorelines. Some captains began steering their vessels toward protected harbours where they could wait out the storm. Others pressed forward. For many ships, turning around meant adding days to their journey. Harbours were not always nearby, and navigating into them during rough conditions could be just as dangerous as remaining in open water. Meanwhile, the atmosphere above the lakes continued changing. As the different pressure systems moved closer together, the difference between high-pressure and low-pressure regions increased dramatically. The larger this difference becomes, the stronger the wind tends to blow. Air naturally moves from areas of high pressure toward areas of low pressure, and when the contrast grows intense, the resulting winds can become extremely powerful. By the evening of November the 7th, the pressure drop across the region was becoming significant. Meteorologists at the time recorded readings that suggested the storm was strengthening faster than expected. Winds reported by ships and coastal stations were already reaching dangerous levels. Waves were rising higher than usual for early November. Still, the most violent part of the storm had not yet arrived. The lakes, with their enormous surface area, were providing the storm with a steady supply of moisture and energy. Cold air sweeping across the relatively warm water created strong upward currents in the atmosphere. These currents helped deepen the developing low-pressure system. In simple terms, the lakes were helping the storm grow. Night fell across the region, with strong winds already shaking coastal towns. In many places, rain turned into snow as temperatures dropped further. The snow did not fall gently. It blew sideways across streets and harbours, pushed by powerful gusts. Out on the open water, ships climbed and plunged through rising waves. Crews worked through the darkness, adjusting course, securing cargo, and watching the sky. Many of them had seen storms before. They had felt the lakes grow rough and had navigated through heavy weather. But the conditions forming around them were becoming something far larger than a typical November gale. The atmosphere above the Great Lakes was now preparing to unleash one of the most powerful inland storms ever recorded in North America. And by morning, the wind would grow even stronger. By the time the morning of November 8th arrived across the Great Lakes region, something in the air had clearly changed. The previous day had already been uncomfortable. Winds had been strong, waves had been rising, and clouds had thickened across the sky. Sailors and dock workers had noticed the shift and spoken about it quietly among themselves. But storms were part of life on the lakes. Rough weather alone was not unusual. What made this morning different was the sudden intensity of everything. The wind was no longer simply strong, it had become relentless. Across Lake Huron, Lake Michigan, and Lake Superior, the atmosphere seemed to tighten like a giant invisible spring. Air pressure dropped rapidly as the storm system deepened. The difference between surrounding high-pressure air and the low-pressure centre over the lakes created a powerful force that pulled air inward from every direction. That did not move gently. It rushed toward the storm with violent speed. Weather stations around the region began reporting wind gusts exceeding 70 miles per hour. In modern measurements, that is strong enough to qualify as hurricane-force wind. For people living along the lakes at the time, the comparison to a hurricane did not yet exist in common conversation, but the experience felt similar. The wind roared continuously. Trees bent under the pressure. Chimneys rattled on rooftops. Waves slammed against docks with such force that spray rose high into the air before freezing in the cold. Along the shoreline of Lake Huron, residents who stepped outside that morning could barely stand upright. The wind pushed against them with steady strength, tugging at coats and hats. Snow had begun falling during the night, and now it moved sideways across streets in thick sheets. Visibility dropped to almost nothing in some places. What had begun as a storm was now becoming something much larger. Over the open water of the lakes, the wind had even more room to accelerate. With hundreds of kilometres of open fetch available, the wind poured energy into the surface of the water. Waves rose rapidly. Crests of white foam tore away from the tops of the waves and flew through the air like torn paper. Ships already at sea faced conditions that changed by the hour. Large freighters that had seemed stable the previous day were now climbing enormous swells before dropping sharply into the troughs between waves. When a ship descended into one of those troughs, the surrounding water rose high above the deck. Seconds later, the vessel would climb upward again, engines pushing against the storm. Crews struggled to maintain control. One of the greatest dangers during storms on the Great Lakes is the sudden shift of wind direction. If the wind changes quickly, waves that had been moving in one direction can collide with waves forming from another direction. This creates chaotic seas where water seems to move unpredictably. That was exactly what was beginning to happen. As the storm deepened, winds across different parts of the lakes began blowing from different directions. On Lake Huron, the wind howled from the northwest. On Lake Michigan, it shifted between west and north. Lake Superior experienced strong winds from multiple angles as the storm's circulation tightened. This created wave patterns that sailors described as confused seas. Instead of long, rolling waves moving steadily in one direction, the water became chaotic. Waves crossed each other at sharp angles. Some rose steeply and then collapsed suddenly. Others surged beneath ships in unexpected bursts of motion. Even large vessels struggled to maintain balance in those conditions. Meanwhile, the temperature continued dropping. Cold air pouring down from Canada swept across the lakes and mixed with the moisture rising from the water. Rain that had fallen earlier turned into heavy snow. The snow did not fall softly. The wind grabbed it and hurled it sideways across the water. Visibility shrank dramatically. Captains who might normally see distant ships or shoreline lights miles away now found themselves surrounded by white darkness. Snow, wind, and spray blended together into a blinding storm. Even the horizon disappeared. Navigation became extremely difficult. Compasses still worked, of course, but visual landmarks were gone. Harbour entrances that sailors depended on for shelter were hidden behind the storm. Lighthouses struggled to shine through the swirling snow. Wireless telegraph systems aboard some ships attempted to send messages to nearby vessels and shore stations. These early radio systems were valuable tools, but they had limitations. Atmospheric conditions sometimes interfered with signals. Messages could be delayed or lost. Some ships managed to report their situation. Operators tapped out short messages describing heavy seas and violent winds. In a few cases, captains requested information about nearby harbours or weather updates, but the storm was growing faster than the information network could keep up with. Along the coastlines, people began realising that the weather had turned dangerous. In towns scattered around the lakes, snow piled quickly against buildings. Wind-driven waves crashed against harbour walls, sending water spraying into the streets. Telegraph poles swayed violently in the wind. Some lines snapped under the strain, cutting communication between towns. Railways slowed as snow covered the tracks. Roads became difficult to travel. Still, the most dramatic events were unfolding far from shore. On Lake Huron, several large cargo ships had already been caught in the centre of the storm. These freighters carried heavy loads of iron, ore, coal and grain. Their hulls were strong, but the waves they faced were unlike anything most crews had experienced. Some waves reached heights of more than 10 metres. To imagine this, picture a wall of water rising as tall as a 3-storey building. Now imagine that wall moving toward a ship while another wave approaches from the side. Ships climbed these walls slowly, engines straining as the bow lifted upward. When the crest passed beneath the hull, the vessel would drop sharply into the trough behind it. Water crashed across the deck, soaking everything in freezing spray. Every piece of exposed metal began collecting ice. Ice accumulation became a growing threat as the storm continued. When waves smashed against the hull, water sprayed high into the air. In the freezing temperatures, that spray turned instantly to ice when it landed on the ship. Railings, ropes, lifeboats and cargo hatches began coating with thick layers of frozen water. The weight added up quickly. Crews rushed across decks with axes and hammers, trying to break the ice away before it became too heavy. But working outside during hurricane-force winds and freezing spray was extremely dangerous. Men had to tie themselves to railings to avoid being blown overboard. Every minute outside exposed them to bitter cold and crashing waves. Inside the wheelhouses, captains focused on keeping their vessels pointed correctly into the wind. If a ship turned broadside to the waves, the force of the water could roll it severely or even capsize it. Maintaining the correct angle was exhausting work. The wheel had to be adjusted constantly as gusts shifted the vessel's direction. Engines had to maintain steady power despite the violent movement of the ship. One mistake could allow a wave to strike the vessel from the side with devastating force. As the morning passed, the storm intensified even further. Meteorological readings later showed that the central pressure of the storm dropped extremely low for an inland system. This deep pressure created stronger and stronger winds as air rushed inward toward the centre. In many places, the wind now exceeded 80 miles per hour. The lakes roared under the pressure. Onshore observers described the sound as continuous thunder. Waves pounded the shoreline again and again. Some harbours experienced water surges that flooded docks and warehouses. Snowfall continued increasing as the cold air mass expanded across the region. What made the storm especially dangerous was its size. Instead of affecting only one lake, the storm covered nearly the entire Great Lakes system at the same time. Ships that attempted to move from one lake to another found the same violent conditions waiting for them. There was no clear path to safety. Throughout the day, more ships reported trouble. Some captains tried steering toward protected shorelines, where land might reduce the height of the waves. Others attempted to reach harbours they knew well, hoping to anchor safely until the storm passed. But navigation in the blinding snow made these attempts extremely risky. Several vessels simply disappeared from communication. Wireless stations attempted to call them repeatedly. No answer came back through the storm. Along the shorelines, residents continued watching the lakes with growing unease. The wind never seemed to pause. Snow filled the air like swirling dust. The water beyond the harbour walls looked wild and chaotic. Few people yet realised how many ships were fighting for survival out there. The storm that meteorologists would later call the White Hurricane had now reached full strength, and the most dangerous hours were still ahead. By the afternoon of November 8th, the storm over the Great Lakes had reached a level of intensity that few people in the region had ever witnessed. The wind had been strong since early morning, but now it seemed to be doing something entirely different. Instead of arriving in occasional gusts, it had become a constant force pressing across the lakes and shorelines without pause. People living near the water described the sound first. It was not the normal whistle of wind around buildings or the rush of air through trees. Instead, it was a deep, steady roar that filled the air continuously. The sound came from several directions at once. Wind pushed across rooftops, swept through streets, rattled windows, and slammed into the shoreline where enormous waves were crashing against stone walls and docks. Outside, even walking became difficult. In cities like Cleveland and Detroit, residents who stepped outside struggled to keep their balance. The wind pushed hard enough to knock hats from heads and tear loose objects from porches and yards. Snow that had begun falling earlier in the day was no longer drifting downward. It was racing sideways across the ground, pulled along by the storm. This kind of wind was unusual for the region. Most storms that passed through the Great Lakes produced strong gusts that came and went. But the winds now blowing across the lakes were not behaving like ordinary storm winds. They were sustained, violent, and increasingly powerful. Weather stations across the region began recording measurements that surprised even experienced observers. Some stations reported sustained winds of 60 miles per hour. Others measured gusts reaching 70 or 80 miles per hour. In a few locations, the instruments recorded winds approaching 90 miles per hour. Those numbers placed the storm firmly in the range of hurricane-force winds. Yet hurricanes normally form over warm tropical oceans where vast amounts of heat energy are available. The Great Lakes, despite their enormous size, are located far from the tropics and surrounded by cold land masses during autumn. So how could a storm over inland lakes produce winds comparable to a hurricane? The answer lies in the structure of the atmosphere during that week. Several days earlier, a large cold air mass had begun moving southward from Canada. This air mass was extremely cold and dense, pushing downward across the central part of the continent. At the same time, a somewhat warmer and more humid air mass was drifting northward from the southern United States. When these two air masses met near the Great Lakes, the atmosphere became unstable. Cold air naturally sinks beneath warmer air, while warmer air tends to rise. As the two air masses collided, powerful upward motions developed in the atmosphere. These rising currents helped strengthen the developing low-pressure system over the region. As the pressure dropped, the difference between the low-pressure centre and the surrounding high-pressure air grew larger. That difference is what drives wind. Air naturally moves from areas of high pressure toward areas of low pressure. When the pressure difference is small, the wind remains gentle. But when the difference becomes large, the air accelerates rapidly as it rushes toward the lower pressure area. During the White Hurricane storm, that pressure difference became enormous. Meteorologists later calculated that the central pressure of the storm dropped to around 968 millibars. For comparison, many powerful ocean storms fall within a similar pressure range. That meant the atmosphere above the Great Lakes had created a pressure gradient strong enough to generate extreme winds, but pressure difference alone does not explain everything that happened. The size of the Great Lakes also played an important role. Over land, wind tends to slow down because it encounters obstacles. Trees, buildings, hills, and uneven terrain all create friction that reduces wind speed. But over water, especially large bodies of water like the Great Lakes, there are far fewer obstacles. The wind can move freely across the surface. This allowed the storm's winds to accelerate dramatically as they swept across hundreds of kilometers of open water. Once the wind gained speed, it transferred energy directly into the surface of the lakes, building enormous waves and throwing spray high into the air. Ships caught in the storm experienced these winds in the most direct way possible. Out on Lake Huron, freighters struggled to hold their course as the wind battered their hulls. Even large steel ships weighing thousands of tons were pushed sideways by the force of the storm. Steering required constant attention. A moment of distraction could allow the wind to swing the bow away from the waves. If that happened, the ship could become dangerously exposed. When waves strike the side of a vessel instead of the bow, the force can roll the ship violently. Water may crash across the deck, flooding equipment and threatening to break loose cargo or lifeboats. Captains tried to keep their ships facing directly into the wind whenever possible. But the wind itself was not steady. One of the most frightening aspects of the storm was how quickly the wind direction could change. Because the storm system covered such a large area, different parts of the lakes experienced winds from slightly different directions. As the centre of the storm moved and deepened, those directions shifted. A ship that had been steering into the wind might suddenly find the wind hitting from the side. Crews struggled to respond quickly enough. Meanwhile, the wind continued strengthening. Observers on shore described seeing waves breaking far beyond the harbour walls. Spray rose so high that it looked like clouds drifting above the water. In some places, the wind carried this spray hundreds of metres inland before it fell back to the ground as freezing droplets. Those droplets quickly formed ice. Trees near the shoreline became coated in frozen layers. Power lines sagged under the weight. Windows facing the lake collected thick sheets of ice as spray struck them again and again. Inside houses, the wind rattled doors and shook walls. Along the waterfronts, dock workers and harbour officials began realising that the storm had become something extraordinary. Storm signals had already been raised earlier in the week, but now the situation seemed far beyond ordinary warnings. Some ports attempted to guide incoming ships towards shelter, but visibility had collapsed. The snow blowing across the lakes had grown heavier as the cold air deepened. Instead of gentle snowfall, the storm produced thick bands of snow that moved like white curtains through the air. Combined with the spray from the waves, this created a blinding mixture of snow and water. Ships sometimes could not see the shoreline until they were dangerously close. Even lighthouse beams struggled to penetrate the storm. The powerful lights that normally guided sailors through the darkness were scattered by snow and spray, creating glowing halos instead of clear signals. The wind also began affecting communication systems. Telegraph lines running between towns snapped in several places as poles bent under the pressure. Wireless radio signals from ships were sometimes interrupted by electrical interference in the storm clouds. Messages that did arrive carried troubling reports. Some ships described waves breaking over the entire deck. Others reported severe icing that threatened the stability of the vessel. A few messages were brief and urgent, requesting assistance or reporting that the ship was struggling to maintain control. Then some ships stopped responding entirely. For families waiting in port cities, this silence would later become one of the most painful parts of the disaster. But during the storm itself, most people did not yet know how many ships were fighting the wind at that moment. Out on Lake Superior, Lake Michigan, and Lake Huron, captains continued battling the storm, hour after hour. Engines roared as vessels pushed against the waves. Crew members moved carefully across ice-covered decks, breaking frozen spray away from equipment whenever possible. The wind never seemed to weaken. In fact, during the late afternoon and evening it grew even stronger. Meteorologists studying the storm later found that the low-pressure system had intensified rapidly as it moved across the lakes. The circulation tightened, pulling air inward faster and faster. This process is similar to what happens when tropical hurricanes strengthen over warm oceans, but this storm was feeding on the unusual atmospheric conditions created by the collision of air masses and the warmth of the lakes themselves. It had become an inland cyclone of enormous strength. By nightfall on November 8th, winds across parts of the Great Lakes were estimated to be approaching hurricane category levels, and still the storm continued building. Ships already struggling through the chaos now faced another danger that would make survival even harder. because as the winds howled across the lakes, the snow began to fall even harder. As the storm continued intensifying across the Great Lakes on November 8th, another transformation was quietly unfolding in the atmosphere above the water. What had begun earlier as cold rain mixed with occasional snow was now becoming something far more severe. The temperature continued dropping rapidly as a massive surge of Arctic air pushed south across the region. That cold air changed the nature of the storm completely. Rain disappeared. In its place came snow. But it was not the quiet snowfall people often imagine during winter evenings. This snow behaved differently. It moved with the wind rather than falling gently through the air. Across the lakes and surrounding towns, the snow began travelling sideways. Meteorologists would later describe the phenomenon as a blizzard. At the time, many people simply described it as white darkness. The wind, which had already reached extreme speeds, grabbed the falling snowflakes and hurled them across the landscape. Instead of drifting downward, the flakes shot through the air like fine grains of sand carried by a powerful current. Standing outside during those hours became almost impossible. In cities along the shores of Lake Michigan and Lake Huron, people who opened their doors were immediately struck by the force of the storm. The snow rushed past their faces at such speed that it stung their skin. Breathing in the wind felt like inhaling cold needles. Within minutes, clothing became coated with frozen snow. Visibility collapsed. During ordinary snowfall, people can still see buildings, streets, and distant lights. But in a true blizzard, the snow and wind combine to create what meteorologists call whiteout conditions. The air fills with swirling snow that reflects light in every direction. The result is a strange visual effect where sky, ground, and horizon blend together. There is no clear direction. People walking through the streets of shoreline towns described losing sight of houses only a few meters away. Street lamps appeared as faint, glowing circles in the storm before disappearing again behind blowing snow. On the open lakes, the effect was even more severe. Ships fighting the storm already struggled with towering waves and violent winds. Now the snow added another dangerous problem. Crews stationed on deck could barely see the bow of their own vessel through the swirling white air. The horizon vanished entirely. Without visual reference points, it became extremely difficult for captains to judge the movement of the waves or the position of nearby ships. Navigation instruments helped, but even those could not replace the value of clear visibility. Many captains relied heavily on their sense of motion and the feel of the ship beneath their feet. A sudden tilt could signal that a large wave was approaching. A change in engine vibration might indicate that the ship had shifted off its intended course. Every sensation mattered during those hours. Meanwhile, the snow continued intensifying. Cold Arctic air moving across the relatively warm surface of the lakes created powerful upward currents in the atmosphere. These currents lifted moisture into the air where it quickly froze into snow crystals. The process produced enormous amounts of snowfall in a short period of time. Modern meteorologists call this lake effect snow. When cold air flows across warmer lake water, it absorbs moisture and heat. As that air moves farther inland, it cools again and releases the moisture as snow. The result can be heavy snowbands that dump large amounts of snow in specific areas. During the White Hurricane storm, the process operated on a massive scale. The entire lake system was feeding moisture into the atmosphere while the storm circulated above it. Snow formed rapidly and fell in thick, dense clouds that the wind immediately grabbed and flung sideways. Observers later reported snowfall rates of several centimeters per hour in some locations. Combined with hurricane-force winds, this created the blizzard conditions that defined the storm. For ships on the lakes, the snow made an already desperate situation worse. The decks of many vessels were already coated in ice from freezing spray. Each wave that crashed across the bow sent water flying through the air. That water froze instantly upon landing on railings, cables, and equipment. Now the blowing snow added another layer. Snow collected on top of the ice, forming thick frozen drifts across the deck. The weight increased steadily as the storm continued. Crew members tried to shovel or break the accumulation away, but the wind made the task extremely difficult. Imagine standing on a moving steel deck, tilted sharply as waves lift the ship upward. The wind screams past your ears at nearly 80 miles per hour. Snow blasts across your face while freezing water crashes over the side. That was the environment sailors were working in. Some crew members had to crawl across the deck to avoid being knocked over by the wind. Others tied themselves to railings with rope so they would not be swept away. Even simple tasks required tremendous effort. Opening a hatch, securing a rope, or adjusting a cable could take several minutes as sailors struggled against the storm. Their gloves quickly stiffened with ice. Metal surfaces became dangerously slippery. Meanwhile, the blizzard continued to erase the world around them. One of the most dangerous consequences of the snowstorm was the loss of visual navigation. Normally, ships travelling the Great Lakes relied heavily on lighthouses, shoreline landmarks, and visible buoys to guide their route. During the White Hurricane, many of those guides disappeared. Lighthouse beams scattered through the snow like diffused halos of light. Buoys vanished beneath waves and drifting snow. Shorelines that might normally appear as dark shapes against the sky were hidden entirely. Captains had to rely on compass headings and their knowledge of the lakes. Even that knowledge had limits when visibility dropped to almost zero. In some cases, ships unknowingly drifted closer to dangerous shoals or rocky shorelines. Strong currents and chaotic waves pushed vessels off their intended paths, while crews struggled to correct course. On land, the blizzard was creating serious problems as well. Railway lines connecting cities around the lakes began shutting down as snowdrifts blocked the tracks. Trains slowed or stopped completely in some areas. Road travel became almost impossible as wind piled snow across highways and streets. Telegraph communication suffered badly. Ice and wind snapped many telegraph wires that connected towns across the region. With those lines broken, information about the storm travelled slowly. Weather stations struggled to send updates to central forecasting offices. This lack of communication meant many people still did not understand how severe the storm had become. Families in port cities waited for ships that were already fighting for survival far out on the lakes. Harbour officials attempted to monitor conditions, but the blizzard limited what they could see. Even experienced observers had difficulty understanding the full scale of the storm. Meteorologists studying the event later would explain that the storm had essentially combined two powerful systems. A large low-pressure cyclone spun over the Great Lakes while cold Arctic air fed the blizzard conditions. The combination created a storm that behaved partly like a hurricane and partly like a winter blizzard. This rare combination was what gave the storm its name, the White Hurricane. The word white referred to the blinding snow that filled the air. The word hurricane described the strength of the wind that drove the storm. Together they formed a description that matched what people experienced during those days. But during the storm itself, no one had yet chosen that name. Sailors, townspeople, and weather observers were simply trying to survive a storm that seemed to grow stronger by the hour. Across the Great Lakes, ships continued battling waves, wind, and blinding snow through the long hours of November 8th. Some captains still believed they could guide their vessels towards shelter if they held out long enough. Others realized that reaching land might no longer be possible. And as darkness approached again, the storm entered its most dangerous phase. By the evening of November 8th, the storm had tightened its grip on the Great Lakes with frightening certainty. What had begun as a violent weather system during the morning had now become something far more dangerous. The wind had not weakened for even a moment. The snow had not slowed. Instead, the entire system seemed to grow heavier, colder, and more relentless as the day wore on. Out on the water, ships were already deep within the chaos. The Great Lakes shipping network in 1913 was busy even this late in the season. Freighters carrying iron ore from the mining regions of Minnesota and Michigan were moving towards steel-producing cities along the lower lakes. Coal shipments travelled north. Grain vessels moved east toward ports where cargo would continue toward the Atlantic. Many of these ships had left port before the worst warnings were issued. Captains had seen storms before. Most of them believed they could navigate through rough weather if they handled their vessels carefully. These ships were large, made of steel, and designed specifically for the heavy conditions that sometimes developed on the lakes. But the storm that had formed across the region was testing those limits. Across Lake Huron alone, dozens of vessels were attempting to cross the water when the storm reached full strength. Some ships were heading north. Others were moving south toward the St. Clair River and Lake Erie. A few had already tried turning back toward harbours along the Michigan or Ontario coast. Unfortunately, the storm was now too large for simple escape. Wherever a ship turned, the same violent wind and waves waited ahead. Take a moment to imagine the conditions on one of those freighters. The vessel rises slowly on the front of a massive wave. The bow lifts higher and higher until the propeller at the stern briefly struggles to stay beneath the water. Then the ship tips forward as the crest passes beneath the hull. The entire vessel plunges downward into the trough behind the wave. Seconds later, another wall of water rises ahead. The deck is already coated with ice from freezing spray. Each time a wave crashes across the bow, water explodes upward and freezes instantly in the cold air. Railings, ladders, cargo hatches and lifeboats all begin collecting thick layers of ice. Crew members move cautiously across the deck with axes and hammers. Their job is to break the ice away before it grows too heavy. Ice accumulation is extremely dangerous for ships because it raises the centre of gravity. If enough ice builds up on the upper parts of the vessel, the ship can become unstable. But performing this work during the White Hurricane was almost impossible. The wind screamed across the deck with hurricane strength. Snow and spray blasted through the air like a frozen storm of sand. Even standing upright required careful balance. Many sailors tied ropes around their waists and secured themselves to railings while working. Without those lines, the wind could easily throw a man across the deck or into the freezing water. Inside the wheelhouse, the captain and helmsman fought to maintain control. The steering wheel had to be adjusted constantly as the ship was pushed by wind and waves. Engines strained against the storm, maintaining just enough forward power to keep the bow facing into the waves. If the vessel turned sideways, even briefly, the results could be catastrophic. A powerful wave striking the side of a ship can roll it violently. Water can pour across the deck and into cargo holds or engine compartments. In extreme cases, the vessel may capsize entirely. Captains knew this risk well. That is why many of them chose to keep their ships pointed directly into the wind, rather than attempting to run with the waves or change direction toward shore. But that strategy came with its own problems. Holding a ship against hurricane-force winds requires enormous engine power and precise steering. If the engine faltered or the rudder lost effectiveness for even a moment, the ship could lose its heading. Several vessels experienced exactly that situation during the storm. Wireless telegraph messages from ships across the lakes began reporting serious difficulties. Operators tapped urgent signals into their equipment while waves slammed against the hull. Some messages described massive waves breaking over the bow. Others warned about heavy ice forming on the decks and superstructures. A few ships reported losing lifeboats or deck equipment after waves tore them away. The storm was not only attacking ships with wind and water, it was also dismantling their ability to respond. Visibility had dropped to nearly zero in many areas. The sideways snow filled the air with a thick white haze. Even powerful lighthouse beams struggled to penetrate the storm. Ships attempting to locate safe harbour often found themselves unable to see the shoreline until they were dangerously close. On Lake Huron, one of the busiest shipping routes in the system, the situation became especially severe. Large freighters were scattered across the lake, each fighting its own battle with the storm. Waves climbed higher with every passing hour as the wind continued feeding energy into the water. Some waves were estimated to reach heights of 10 meters or more. When a wave of that size crashes into a steel hull, the impact shakes the entire vessel. Plates of metal groan under the pressure. Water floods across the deck, carrying loose objects with it. For sailors standing outside, each wave felt like being struck by a wall of freezing water. Inside the ships, conditions were hardly comfortable either. Cabins shook violently as the hull pounded through the waves. Crew members trying to move through the corridors had to brace themselves against walls to keep from falling. The constant motion made even simple tasks difficult. Cooking meals in the galley became nearly impossible as pots slid across stoves. Sleeping was out of the question for most sailors. Everyone remained alert, listening for any unusual sounds that might signal damage to the ship. The fear that haunted many crews during those hours was the possibility of structural failure. Still freighters were strong, but they were not indestructible. Repeated impacts from massive waves could strain the hull over time. If the ship struck a wave at the wrong angle, the force could bend or crack structural components. Once water begins entering the hull in heavy seas, the situation becomes extremely dangerous. Pumps can remove water for a while, but if flooding continues, the ship may gradually lose buoyancy. Combined with ice accumulation and violent waves, the vessel could eventually sink. Unfortunately, this exact scenario began unfolding during the White Hurricane. As night approached on November 8th, several ships stopped responding to wireless calls. At first, other vessels assumed the radio operators were simply busy dealing with the storm. Communication during severe weather was often irregular. But as hours passed with no response, concern began growing. Ships attempted to call their missing companions again and again. Silence answered. In some cases, other captains believed they saw faint lights through the storm where a vessel might be struggling in the distance. But the snow and waves made it difficult to confirm anything. Meanwhile, the storm continued raging. Onshore observers along Lake Huron watched the lake with growing dread. Even from the safety of land, the conditions looked terrifying. Waves crashed against breakwaters and harbour walls with explosive force. Spray rose high into the air before freezing into ice. Snow filled the streets of shoreline towns. Few people yet understood how many ships were caught out there in the darkness. The lakes that had once served as busy highways for trade had now become violent, frozen battlegrounds. Freighters that had carried thousands of tons of cargo only days earlier were now fighting simply to remain afloat. And as the long night continued, some of those ships would face a final struggle against the storm. As the storm continued to tighten its grip across the Great Lakes on November 8th, the violence of the weather was no longer limited to the open water. Along the shorelines, in the places that sailors normally trusted as safe shelter, the storm was transforming the harbours themselves into something unrecognisable. Ports that usually offered protection from rough water were beginning to freeze. During calmer winters, ice on the Great Lakes forms gradually. Temperatures fall slowly through late November and December. Thin sheets of ice begin appearing near the shoreline first, forming quiet patterns along the edges of the water. Harbours sometimes develop floating plates of ice that bump gently against docks and piers. But the conditions during the White Hurricane were nothing like that slow seasonal process. The storm had brought together two powerful forces at once. The first was the extreme wind that continued roaring across the lakes. The second was the sudden arrival of very cold Arctic air. When those two forces combined with the constant spray from massive waves, the result was rapid freezing across large areas of shoreline. In simple terms, the storm was building ice almost as quickly as the wind could throw water into the air. Along breakwaters and docks, waves crashed repeatedly against the stone and steel structures. Each wave exploded upward into thousands of droplets that flew through the freezing air. The temperature had fallen low enough that these droplets froze almost instantly when they touched any surface. Railings, ladders and ropes began collecting thick layers of ice. Harbour walls slowly transformed into frozen ridges of white and pale blue. Lamps along the docks became trapped inside shells of ice that formed around them like glass. In some places, the ice grew so thick that it changed the shape of the harbour itself. Ships approaching these ports discovered that their familiar entrances no longer looked the same. The usual lines of docks and pilings had been buried beneath frozen spray. Channel markers disappeared under the growing ice formations. Even the outlines of the harbour walls became difficult to recognise. The snow made everything worse. Blizzard conditions continued across much of the region, filling the air with blowing snow that mixed with the freezing spray from the waves. Visibility near the shoreline was sometimes no better than it was on the open lakes. Captains trying to reach shelter found themselves facing a new and unexpected problem. The harbours were becoming dangerous too. Under ordinary circumstances, entering a harbour during a storm offers protection because the surrounding land blocks the worst of the waves. Once a ship passes the breakwater, the water becomes calmer and the vessel can anchor safely until the storm passes. But during the White Hurricane, the storm surge and powerful wind pushed enormous waves directly into many harbours. Instead of calm water behind the breakwalls, ships encountered violent churning waves that bounced unpredictably between the structures. Water surged in and out of the harbour entrances as the wind shifted direction. This movement carried floating ice and debris through the narrow channels. Ships attempting to enter had to navigate through ice-covered docks, while waves continued slamming against their hulls. For some captains, the risk of attempting to enter a frozen harbour became greater than the danger of staying in open water. Imagine steering a large steel freighter through a narrow harbour entrance, while wind screams across the deck, snow fills the air, and waves crash into the sides of the vessel. Now imagine that the harbour walls themselves are coated with thick ice, making them slippery and difficult to judge in the blizzard. One wrong turn could send the ship crashing directly into the frozen structure. Several vessels that attempted to reach shelter during the storm were forced to abandon the effort and turn back toward open water. Harbour officials on shore could see the struggle unfolding. Lighthouse keepers, dock workers, and residents of coastal towns watched the lakes with growing concern. Through the swirling snow, they occasionally spotted ships moving slowly near the harbour entrances, their outlines barely visible through the storm. Sometimes the vessels turned away again, disappearing back into the white haze. The people on shore could do little to help. Rescue boats were useless in those conditions. The waves were far too large, and the wind far too powerful. Even standing on the docks was dangerous as freezing spray coated every surface with ice. In several towns, harbour crews attempted to keep access points clear by breaking away ice with tools. They worked along the docks with hammers and poles, trying to prevent ice from sealing off the entrances completely. But the storm rebuilt the ice faster than it could be removed. Each new wave added another frozen layer. The result was a strange and unsettling sight. Harbours that normally bustled with ships and workers were slowly turning into frozen sculptures shaped by wind and water. Piers looked like jagged white ridges. Boats tied along the docks became encased in thick shells of ice that hung from their railings and masts. Even buildings near the water began collecting frozen spray. Windows facing the lake frosted over completely. Doors became difficult to open as ice built up along the frames. Trees near the shoreline bent under the growing weight of frozen water on their branches, and still the wind continued. What made the situation especially dangerous was that many ships had been counting on these harbours as safe destinations. Captains had plotted their routes expecting that they could reach shelter if conditions worsened. Now those safe places were disappearing. On Lake Huron, several freighters that attempted to reach ports along the Michigan shoreline encountered ice-covered harbour entrances and violent waves pushing directly inward from the lake. With visibility nearly zero, navigating through those narrow passages became nearly impossible. Some captains attempted to anchor offshore and wait for the storm to pass. But anchoring during hurricane-force winds on the Great Lakes carries serious risks. The force of the wind can drag the anchor across the lake bed, allowing the ship to drift uncontrollably toward shore. If the vessel drifts too close, the waves can push it directly onto rocks or sandbars. This process, known as grounding, has destroyed many ships over the centuries. During the White Hurricane, several vessels came dangerously close to that fate. Meanwhile, the freezing conditions continued building ice on every exposed surface. Ships fighting their way through the storm found that their decks were now coated with both frozen spray and drifting snow. Crew members worked constantly to break away ice before it grew too heavy, but the effort was exhausting. Many sailors had already been awake for long hours battling the storm. The cold drained their energy quickly. Gloves and clothing stiffened as ice formed across them. Even the rigging of the ships began freezing solid. Ropes that normally remained flexible became rigid with ice, metal fittings stuck in place. Lifeboat davits froze into awkward positions that would make launching the boats extremely difficult if the crew ever needed them. All of these problems were happening at once. Ships could not rely on safe harbours because the storm had turned those shelters into frozen traps. Remaining in open water meant enduring the full force of the wind and waves. There was no easy choice left. For many captains, the only option was to keep fighting the storm and hope the ship would survive until conditions improved. But the storm was not finished yet. The wind continued roaring across the lakes through the night, and somewhere out in the darkness several ships were already beginning their final struggle against the white hurricane. As the storm pushed deeper into its second day, the Great Lakes were beginning to change in a way that few people had ever witnessed so suddenly. The wind had already reshaped the water, building waves tall enough to threaten even the largest freighters. The snow had erased visibility across huge areas of the region. Harbours had started turning into frozen corridors of ice and spray. But now another transformation was quietly unfolding across the surface of the lakes themselves. The water was beginning to freeze. Normally ice on the Great Lakes formed slowly. Temperatures fall gradually during late November and December. Thin sheets of ice appear first in protected bays and along sheltered shorelines, where the water remains calm. Over time, those thin layers grow thicker as more cold air moves across the region. It is a process that usually takes weeks. But the storm of November 1913 had created conditions that sped the process up dramatically. Cold Arctic air had poured south across the lakes with enormous force. At the same time, hurricane-strength winds were whipping the surface of the water into towering waves that broke continuously across the lake. Each crashing wave threw thousands of droplets of water high into the freezing air. Those droplets froze almost instantly. Instead of forming solid ice sheets across the entire lake, the freezing process appeared first in countless smaller forms. Spray, frozen in mid-air, landed as tiny crystals. Snow mixed with partially frozen droplets. Slush began forming across the tops of waves and along the edges of the water. The entire surface of the lake began filling with fragments of ice. For sailors trapped out on the water, the change was immediately noticeable. Earlier in the storm, the waves had been violent but fluid, rolling beneath the ships in powerful swells. Now those waves carried a strange texture as frozen fragments moved through the water. Slushy ice gathered along the edges of the deck and against the hull. The freezing spray became heavier. Every wave that struck the ship sent more water flying upward. The air temperature had dropped far enough that the spray froze the moment it touched metal surfaces. Layers of ice began growing across the ships faster than crews could remove them. Railings turned into thick frozen bars. Ropes stiffened into rigid lines that barely moved. Lifeboats hanging from their davits developed heavy shells of ice around their sides. Even the windows of the wheelhouse sometimes collected frozen spray that needed to be chipped away to maintain visibility. The process created a dangerous cycle. As ice accumulated on the upper parts of the ship, the vessel's centre of gravity slowly shifted upward. That made the ship less stable in the rolling waves. A vessel that might normally recover easily from a strong wave could begin leaning farther to one side before righting itself. If the ice continued building, the ship could eventually reach a point where it could no longer correct its balance. Crews worked constantly to prevent that from happening. Sailors climbed across the decks with axes and hammers, striking the frozen layers again and again to break them loose. Chunks of ice slid across the deck and were swept away by the wind or washed back into the lake by the next crashing wave. But the storm replaced the ice almost immediately. Within minutes, another wave would slam against the bow and coat everything with a new layer of freezing spray. Working in those conditions required enormous effort. The wind howled across the decks at hurricane speed, making it difficult to stand upright. Snow blasted through the air like a frozen cloud of dust. Each sailor had to focus carefully on every step to avoid slipping on the ice-covered surface. Many crew members tied ropes around their waists and secured themselves to parts of the ship while they worked. Without those lines, one strong gust could easily throw a person across the deck or into the water. Meanwhile, the freezing process was spreading across other parts of the lakes as well. Near shorelines, the water that surged into harbours during the storm began forming thicker layers of ice. Waves carried slushy ice into protected bays, where the motion of the water slowed enough for it to gather together. Large patches of floating ice began appearing. These patches moved slowly across the surface of the water, pushed by the wind and currents. When they collided with ships or harbour structures, they produced grinding sounds that echoed across the storm. Some sailors described hearing the ice scraping along the hull beneath their feet. The sound was unsettling because it meant the water was no longer entirely open. For ships trying to navigate during the storm, floating ice added another danger. Ice fragments could damage propellers or clog water intake systems used to cool the engines. Large pieces could even become trapped against the rudder, interfering with steering. Captains had to remain constantly aware of these risks while still fighting the enormous waves. In several areas around the lakes, observers on land reported seeing strange mixtures of snow, ice and spray moving through the air together. Waves crashed against the shoreline, throwing water high into the wind where it froze before falling back to the ground as frozen pellets. The beaches and harbour walls collected thick layers of ice. Over time, those layers grew into heavy ridges that looked almost like frozen waterfalls hanging over the sides of docks and breakwaters. Buildings near the water developed long icicles that formed from repeated blasts of freezing spray. The landscape itself seemed to be turning into ice, but out on the lakes, the freezing water was still moving. The violent motion of the storm prevented large sheets of solid ice from forming across the open water. Instead, the surface filled with a mixture of slush, foam, and scattered fragments of ice that travelled with the waves. Each wave carried pieces of ice up and over the bows of ships. When those frozen fragments landed on deck, they added to the growing weight that crews struggled to remove. Some sailors reported that the decks felt as if they were gradually being buried beneath layers of frozen water. Even the masts and smokestacks of ships collected ice. The higher parts of the vessels were especially vulnerable because freezing spray rose high into the air when waves broke. Over time, the ice thickened around antennas, cables, and ladders. The ships began looking less like smooth steel machines and more like frozen sculptures. From a distance, their outlines were softened by layers of ice and snow. Inside the engine rooms, conditions remained slightly warmer, but the strain on the machinery continued increasing. Engines had to maintain steady power to keep the ship facing the waves. If the vessel slowed too much, the wind could push it sideways into the waves. Engineers monitored gauges carefully, making adjustments to maintain power while avoiding overheating or mechanical failure. Every part of the ship was under stress. Above them, the storm continued raging across the lakes with no sign of weakening. Meteorologists studying the event later would describe the conditions as a rare combination of extreme wind, intense snowfall, and rapid freezing temperatures. The lakes were feeding moisture into the storm while the cold Arctic air froze that moisture almost instantly. The result was a storm environment where water and ice existed side by side in constant motion. Ships battling the storm faced not only massive waves and violent winds, but also a growing layer of ice that threatened their stability. And as night approached once again over the Great Lakes, some of those ships were already reaching the limits of what they could endure. As the storm raged across the Great Lakes through the night of November 8th, and into the early hours of the next day, the chaos on the water was matched by something equally dramatic on land. The blizzard that had begun earlier in the storm was now reaching its full strength. Snow continued falling across the region without pause, driven by hurricane-force winds that pushed it across the landscape in endless waves of white. For many towns and cities along the lakes, the transformation happened almost entirely during the night. People who had gone to bed hearing the wind outside their windows woke to a world that looked completely different. Streets that had been visible the evening before were now buried beneath deep drifts of snow. Cars, wagons, and rail lines had disappeared under thick layers of white. The familiar shapes of houses, fences, and trees were softened by heavy snow piled against them. In some places, the drifts were taller than a person. The wind had sculpted the snow into uneven ridges across the streets, piling it higher in some places while leaving narrow gaps in others. Doorways were blocked by frozen walls of snow that had to be pushed aside before anyone could step outside. Even opening the front door of a house could require effort. Across cities like Cleveland, Buffalo, Detroit, and smaller towns scattered along the lake shores, residents stepped outside cautiously and immediately felt the full force of the storm. The wind had not weakened during the night. It continued to howl through the streets, driving fresh snow through the air in thick sheets. Walking outside was extremely difficult. People trying to move through the streets leaned forward against the wind to keep their balance. The snow flying through the air made it hard to see more than a few meters ahead. In some places, residents described feeling completely disoriented because the snow erased all familiar landmarks. Even the sky seemed to disappear. The blizzard conditions created what meteorologists call whiteout visibility. Snowflakes reflecting light in every direction filled the air so completely that the boundary between ground and sky vanished. Buildings appeared only as vague shapes until someone was standing directly in front of them. For people trying to travel through the city, this created real danger. More than a few residents became lost while attempting to walk only short distances from their homes. Familiar streets looked completely different under the deep drifts of snow. Wind erased footprints almost immediately, removing any sign of where someone had walked. Rail transportation across the region quickly began shutting down. Trains that normally carried passengers and cargo between cities could not move through the heavy snowdrifts covering the tracks. Railway workers attempted to clear the lines with shovels and equipment, but the wind continued piling snow back onto the rails faster than it could be removed. Several trains became stranded along their routes. Passengers inside those trains waited for hours while crews attempted to reopen the tracks. Some travellers remained trapped overnight while the storm continued raging outside the windows. Road travel was no easier. Horse-drawn wagons, which were still common in many areas at the time, struggled to move through the deep snow. Wheels became stuck in drifts that reached up to the axles. Horses had difficulty pulling heavy loads through the icy streets. Even the earliest automobiles of the era were useless in these conditions. Most vehicles simply could not operate in such deep snow. Engines stalled or wheels spun helplessly against the icy surface beneath the drifts. Communication across the region also began breaking down. Telegraph lines that connected cities throughout the Great Lakes region had already suffered damage from the storm's wind and ice. During the night, many of those lines snapped completely. Poles bent or collapsed under the weight of frozen spray and heavy snow. Without those telegraph connections, towns lost contact with one another. Weather stations that normally reported conditions to central forecasting offices suddenly went silent. Harbour officials attempting to gather information about ships on the lakes received no new messages. Families waiting for news about loved ones working aboard freighters found themselves cut off from any updates. Meanwhile, the snow continued falling. The storm's circulation pulled moisture from the lakes into the atmosphere, where it quickly froze into snow. As the cold Arctic air passed over the relatively warmer lake water, powerful currents lifted that moisture high into the clouds. The result was an intense snowfall that lasted hour after hour. In some locations around the lake, snowfall totals climbed well beyond what residents normally expected in a single storm. Combined with the constant wind, the snow built deep drifts that blocked streets and piled against buildings. Entire neighbourhoods seemed buried beneath the storm. City crews attempted to clear important roads with shovels and early snowplows, but the effort was often futile. The wind simply pushed fresh snow back into the cleared spaces. Even emergency services struggled to respond to calls. Firefighters and police officers found themselves moving slowly through streets that had turned into frozen corridors between high snowbanks. Some stations had to rely on teams of men with shovels just to keep their own entrances clear. Hospitals faced similar challenges. Doctors and nurses working overnight shifts had difficulty reaching the buildings through the storm. In some cases, medical staff remained inside the hospital for extended hours because travelling home through the blizzard was impossible. Despite these challenges, many residents initially believed the storm was simply another severe winter event. People living around the Great Lakes were accustomed to heavy snowstorms. Winters in the region could produce impressive snowfall totals every year. While the wind and snow of the White Hurricane were certainly extreme, few people yet understood the full scale of the disaster unfolding beyond the shoreline. What they could see was the effect on their own cities. By morning, streets had disappeared beneath deep snow drifts. Power outages occurred in several areas as ice-coated lines failed. Schools and businesses remained closed because employees could not reach the buildings. The storm had effectively frozen daily life. Children peered through frosted windows watching the snow race past the houses. Adults shoveled paths through the drifts leading from their front doors to the street. But even as people worked to clear the snow from their homes and businesses, the storm continued raging over the lakes. And out there, far beyond the snow-covered cities, ships were still fighting for survival in the darkness. As the blizzard continued sweeping across the Great Lakes region, the storm was no longer only a battle between ships and waves. It had begun shutting down the entire network of movement that connected the cities and towns surrounding the lakes. Railways, roads, telegraph lines and shipping routes all started failing at the same time. For people living in the region, the most noticeable change came in the form of silence. Under normal circumstances, cities near the Great Lakes were busy places filled with constant motion. Trains arrived and departed throughout the day, carrying passengers and freight between major industrial centres. Wagons rolled through the streets delivering supplies to markets and warehouses. Steamships sounded their horns as they entered and left harbours. The storm began erasing those sounds. Railways were the first system to struggle. Tracks that crossed open land quickly disappeared beneath thick layers of drifting snow. The blizzard winds pushed snow across the rails faster than crews could clear it. In some places, the snow formed ridges several metres high, creating barriers that locomotives simply could not push through. Train crews attempted to keep their routes open. Railroad companies dispatched workers with shovels and early snow-clearing equipment to break through the drifts. But the conditions were relentless. The wind continued driving fresh snow across the tracks almost as soon as they were cleared. Some locomotives attempted to push forward anyway. The heavy engines churned their wheels against the buried rails while steam poured from the stacks into the freezing air. For a while, a few trains managed to move slowly through the storm. But as the drifts grew deeper, even the most powerful engines were forced to stop. Several trains became stranded along remote sections of track. Passengers inside those cars watched the blizzard through frost-covered windows, while railroad crews worked outside in the wind trying to clear the path ahead. In many cases, the crews eventually realised that continuing forward was impossible. The trains would have to wait for the storm to pass. Railroad stations across the region began filling with delayed travellers who could not continue their journeys. Schedules were abandoned entirely. Dispatchers struggled to track which trains had stopped and where they were located. But communication itself was beginning to fail. Telegraph lines were the nervous system of the railway network. These wires carried instructions from dispatch offices to stations and locomotives across hundreds of kilometres. Without them, coordinating train movement became extremely difficult. The storm was tearing those wires down. Freezing spray from the lakes coated telegraph poles and cables with thick layers of ice. The weight caused some wires to sag dangerously low. In other places, the wind snapped the lines entirely, leaving long stretches of track without communication. When those connections failed, Entire sections of railway effectively disappeared from the network. Dispatchers could no longer contact stations or trains along those routes. They had no way of knowing whether a train was moving, stopped, or in trouble somewhere in the storm. The loss of communication created confusion across the railway system. Some trains remained stranded for many hours simply because no one knew their exact location or how to reach them. Passengers waited quietly inside the cars, bundled in coats and blankets while the wind shook the carriages outside. Meanwhile, roads across the region were becoming just as unusable. In 1913, most road transportation relied on horse-drawn wagons or early automobiles. Both struggled badly in the deep snow. Horses pulling heavy wagons found themselves sinking into drifts that reached up to their chests. Drivers attempted to guide them through narrow paths between snowbanks, but the wind kept filling those paths with fresh snow. In some towns, wagons simply stopped moving. The animals were led back to stables or sheltered areas where they could wait out the storm. Goods that were meant to be delivered across town remained stacked in warehouses or storehouses until travel became possible again. Automobiles faced similar problems. Early motor vehicles were not designed for extreme winter conditions. Their tyres struggled to grip the icy roads hidden beneath the deep snow. Engines sometimes failed to start in the bitter cold. Even when a car managed to move forward, the snowdrift quickly blocked its path. Drivers who attempted to travel outside city limits sometimes discovered that the roads had vanished entirely beneath the storm. Fields, fences and roadways blended together under the drifting snow. Without clear landmarks, navigation became difficult. For many communities, the safest decision was simply to stay indoors. City streets grew strangely quiet as the storm continued. Businesses closed their doors because employees could not reach the buildings. Markets that normally bustled with activity remained empty. Even the usual sounds of transportation faded. No wagons rattled over the cobblestones. No trains whistled from distant rail lines. No steamship horns echoed across the harbours. The storm had created a sudden and unnatural stillness across the cities. This silence carried a deeper meaning for people who lived near the lakes. Normally, harbour towns were filled with the noise of maritime activity. Ships arriving at ports sounded their whistles to signal dock workers. Tugboats manoeuvred freighters through narrow harbour entrances. Cranes clanked as cargo was lifted from ship holds to waiting warehouses. During the White Hurricane, those sounds disappeared. The harbours themselves were nearly empty. Ships that had reached shelter earlier in the storm remained tied to the docks, their crews waiting anxiously for the weather to improve. Ice continued forming along the harbour walls and across the decks of moored vessels. Beyond the breakwaters, the lakes remained hidden behind the blizzard. Residents standing along the shoreline could not see the ships fighting the storm far out on the water. The snow and wind erased the horizon completely. But people understood that many vessels were still out there. Families who had relatives working aboard freighters knew the shipping routes well. They knew which ships had departed the previous day. They knew roughly when those ships were expected to arrive at the next port. Now those expected arrivals were delayed. Without telegraph messages or wireless signals, there was no way to know whether the ships were safe or in trouble. Harbour officials attempted to gather information wherever possible. Lighthouse keepers along the coast watched the storm carefully, hoping to catch sight of ships passing through the snow. Some reported faint lights far out on the lake, though it was often impossible to determine exactly what they were seeing. The blizzard turned every observation into uncertainty. At the same time, the storm continued affecting daily life in unexpected ways. Schools across the region closed because students could not travel safely through the deep snow. Teachers remained at home waiting for roads to be cleared. Factories and mills slowed or stopped production as workers failed to arrive for their shifts. Supply deliveries that normally arrived by train or wagon were delayed indefinitely. Even the postal service struggled to operate. Mail trains that carried letters between cities were stranded along blocked tracks. Local mail carriers attempted to deliver messages on foot, but deep snow made the task slow and exhausting. Entire communities became temporarily isolated. People gathered inside homes, shops and public buildings listening to the wind outside. Some families lit extra lamps and stoves to keep warm as the temperature continued dropping. Through it all, the storm showed no sign of ending. The wind still roared across the frozen lakes. Snow continued falling hour after hour. Railways remained blocked. Roads stayed buried. The Great Lakes region had entered a strange moment where movement itself seemed to stop. And far beyond the silent cities, the ships trapped in the storm were facing the most dangerous hours of the entire disaster. As the storm continued to rage across the Great Lakes, the people facing the most immediate danger were the sailors aboard the ships still trapped on the water. While cities struggled with snowdrifts and frozen railways, the crews out on the lakes had no shelter at all. Their world had narrowed to the decks beneath their feet, the engines deep within the ship, and the towering waves surrounding them on every side. For those sailors, the White Hurricane was not an abstract weather event. It was a constant physical struggle that lasted hour after hour. Most of the men working aboard the freighters were experienced lake sailors. Many had spent years moving cargo across the Great Lakes during every season of the shipping year. They had seen storms before. November gales were a familiar part of their work, and the crews understood how quickly conditions on the lakes could change. But even the most experienced sailors knew that this storm was different. The wind alone was enough to make their work dangerous. It blew across the decks with such strength that standing upright required concentration. Sailors moving from one part of the ship to another often had to hold onto railings or ropes just to avoid being pushed sideways. In some cases, men tied safety lines around their waists while working. These ropes were fastened to secure parts of the ship, so that if a sailor slipped or lost his balance, the line might prevent him from being blown overboard. The freezing water of the lakes in November was deadly cold. Falling into the water during the storm would almost certainly mean death within minutes, so every movement had to be careful. Even walking across the deck became a slow and deliberate process. Ice coated nearly every surface. Boots slipped easily on the frozen steel, especially when waves crashed across the deck and covered everything with fresh water that froze instantly. Meanwhile, the ship itself never stopped moving. The freighters climbed enormous waves and then plunged into deep troughs again and again. Each movement shifted the deck beneath the sailors' feet. A man working near the bow might suddenly find himself leaning sharply forward as the ship dropped into a trough, only to be thrown backward seconds later when the bow rose again. Crew members had to adjust their balance constantly. Despite the danger, their work never stopped. One of the most important tasks during the storm was removing ice from the ship. As freezing spray coated the vessel, thick layers of ice began forming along railings, ladders, cargo hatches and lifeboats. The weight of this ice could eventually make the ship unstable, so sailors armed themselves with axes, hammers and heavy metal bars. They struck the frozen surfaces again and again, breaking chunks of ice loose and pushing them overboard. The work was exhausting, especially in the freezing wind. Each swing of the tool required effort while the ship rocked violently beneath them. The ice fought back in its own way. As the storm continued, new layers formed almost immediately after the old ones were removed. A wave crashing over the bow would send another burst of spray across the deck, and within minutes that spray would freeze solid again. It was like trying to hold back the storm itself. Inside the ship, other crew members worked to keep the machinery running. Engineers monitored the engines carefully as they pushed against the violent waves. Maintaining steady power was critical. If the ship slowed too much, the wind could turn the vessel sideways to the waves. That situation was one every captain feared. When a ship turns broadside to large waves, the force of the water can roll the vessel sharply. Cargo may shift. Water may pour across the deck. In the worst cases, the ship may capsize or suffer structural damage. So the engines had to keep running. Engine rooms were hot compared to the freezing decks above, but the work there was no easier. Engineers watched pressure gauges and temperature dials, while the machinery roared around them. The constant movement of the ship made it difficult to stand still, even inside the metal corridors. Every vibration of the engine carried meaning. An unusual sound might signal damage. A drop in power might indicate that ice or debris had interfered with the propeller. Engineers remained alert for any sign that the machinery was failing. Above them, the captains fought a different battle. Inside the wheelhouse, visibility was almost non-existent. Snow and freezing spray covered the windows repeatedly. Crew members had to scrape away ice from the glass so the captain could see even a small portion of the water ahead. But most of the time, there was little to see. The horizon had disappeared behind the blizzard. The captain steered the ship using instruments, experience, and the feel of the vessel beneath his hands. The steering wheel required constant adjustment. Each gust of wind pushed against the ship differently. Each wave struck the hull with a slightly different force. The captain and helmsman worked together to keep the vessel pointed correctly into the storm. Even a small mistake could allow the ship to swing off course. If that happened, the crew might have only seconds to correct the heading before a large wave struck the vessel from the side. Communication aboard the ships also became difficult. The roar of the wind and crashing waves drowned out normal conversation. Crew members often had to shout to be heard even when standing only a few steps apart. Orders were sometimes repeated several times before everyone understood what needed to be done. Despite these challenges, many crews worked with remarkable coordination. Years of experience had taught them how to move efficiently during dangerous weather. Each sailor understood his role. Some focused on breaking ice, others secured cargo or equipment that might break loose during the storm. Every task contributed to the survival of the ship. Still, fear was impossible to ignore. Even the most seasoned sailors could feel the power of the storm pressing against the vessel. The wind never seemed to weaken. The waves continued growing larger. Ice accumulated faster than crews could remove it. Some sailors later recalled that the storm felt endless. Hours passed without any sign that conditions were improving. Darkness fell and the storm continued exactly as before. Men worked through the night without sleep, driven by the simple need to keep the ship afloat. Occasionally, faint lights appeared through the blizzard. These lights might belong to another ship struggling somewhere in the storm. Sometimes the lights disappeared again within seconds as the snow swallowed them. Those brief glimpses reminded sailors that they were not the only ones facing the storm. Across the lakes, other crews were fighting the same battle. Each ship carried its own group of men working together against wind, water, and ice. Some of those vessels would survive the storm, others would not. But during those hours, the sailors could not think about the outcome. Their focus remained on the next task, the next wave, the next moment. And as the storm continued through the night, the white hurricane would soon begin claiming some of the ships that had ventured onto the lakes. As the storm continued into the night of November 8th and early November 9th, the situation on the Great Lakes began shifting from struggle to tragedy. Until this point, many ships had still been fighting their way through the storm. Crews had been battling ice, wind, and waves, hour after hour, hoping that if they could simply endure long enough, the weather might eventually weaken. But storms of this magnitude do not give every vessel that chance. Some ships had already reached the limits of what their structure, engines, and crews could endure. The White Hurricane was not only a blizzard or a windstorm, it was a combination of violent weather forces that worked together to push ships beyond their breaking point. One by one, ships began disappearing. The first sign of trouble usually came through the wireless telegraph. Several freighters had operators stationed near their radio equipment throughout the storm. These operators tapped out short updates to nearby ships or coastal stations whenever conditions allowed. Most messages were brief, sometimes only a few words describing heavy seas or strong winds. Then, suddenly, the messages stopped. At first, this silence did not seem unusual. The storm interfered with wireless communication constantly. Static from the atmosphere sometimes drowned out radio signals, and operators were often too busy dealing with immediate problems aboard the ship to send messages. But as the hours passed, concern began growing. Ships that had been reporting their position earlier in the storm simply vanished from communication. One of the most heavily affected areas was Lake Huron. The geography of this lake made it particularly dangerous during the White Hurricane. Strong winds blowing down the length of the lake had a long stretch of open water to build enormous waves. By the time the storm reached full strength, those waves had become massive. Some sailors later estimated wave heights reaching more than 10 meters. These waves did not arrive gently. They crashed across the surface of the lake with explosive force, smashing into ships already struggling with ice accumulation and blinding snow. A freighter facing those conditions might fight the storm for hours, but if the vessel suffered even a small failure, the situation could change instantly. A single, powerful wave might tear away lifeboats or deck equipment. Ice could build up faster than the crew could remove it, making the ship dangerously unstable. Cargo inside the hold might shift under the violent motion, affecting the balance of the vessel. Sometimes a ship simply vanished without warning. One moment it was somewhere on the lake, fighting the storm like every other vessel. The next moment it was gone, swallowed by waves and darkness. Rescue efforts during the storm were nearly impossible, even if another ship suspected that a nearby vessel had sunk. Reaching that location safely in the hurricane-force wind and blizzard conditions would have been extremely dangerous. Lifeboats launched into those waves had little chance of survival. Most captains focused entirely on keeping their own ships afloat. As the storm continued through the night, more vessels stopped responding to wireless calls. Captains and radio operators aboard surviving ships tried repeatedly to contact their missing companions. Messages were sent out across the storm asking for confirmation of positions, but the replies never came. Among the ships caught in the storm were several large freighters carrying heavy cargo across Lake Huron. These vessels had departed their ports with experienced crews and strong steel hulls designed for lake navigation. Yet the storm treated them all the same. Waves hammered their sides again and again. Ice built up across the decks and superstructures. Engines strained against the violent movement of the water. Some ships likely lost power during the worst moments of the storm. If the engine stopped or the rudder failed, the ship could quickly turn sideways to the waves. A few enormous waves striking from that direction might be enough to roll the vessel completely. Other ships may have suffered structural damage. Repeated impacts from massive waves can bend metal plates, or weaken the seams between sections of the hull. If water began pouring into the cargo holds, the vessel might slowly lose buoyancy until it finally sank beneath the surface, and all of this happened in darkness. Night had fallen again over the lakes while the storm remained at full strength. Snow filled the air. The horizon disappeared entirely. Even large ships could barely see the water directly ahead of them. For sailors aboard surviving vessels, the knowledge that other ships were disappearing nearby added a heavy tension to every moment. Some crews reported seeing faint distress lights far out on the lake during the night. These lights sometimes flickered briefly through the snow before vanishing again. It was impossible to know exactly what had happened. Perhaps the distant ship had simply turned away. Perhaps the light had been hidden by a wave, or perhaps the vessel had already begun sinking beneath the storm. The uncertainty made the night even more frightening. Meanwhile, onshore communities remained unaware of the full scale of the disaster. The storm had already cut many telegraph lines connecting cities around the Great Lakes. Without reliable communication, news about the ships trapped on the lakes travelled slowly. Harbour officials knew that many vessels were overdue. Ships that should have arrived hours earlier had not appeared. Lighthouse keepers scanning the stormy water saw no sign of them. Wireless stations listening for radio messages heard only static and the occasional signal from ships still battling the storm. Families in port cities began worrying. Many sailors working aboard the freighters came from the same coastal towns where the ships docked regularly. Their relatives followed the shipping schedules closely. When a ship was late, people noticed. But during the storm, no one could say for certain what had happened. It would take days before the full picture emerged. When the weather finally began calming, search vessels and shoreline observers started finding wreckage scattered across parts of the lakes. Pieces of wood, lifeboats, cargo debris, and sometimes entire sections of ships drifted toward shore. These discoveries revealed the truth. Several ships had been lost during the White Hurricane. Entire crews had vanished with their vessels, leaving behind only fragments of wreckage floating in the cold water. The Great Lakes had always carried risks for sailors, but the storm of November 1913 had shown just how quickly those risks could become overwhelming. And as the storm slowly began weakening, the scale of the disaster was only just beginning to unfold. As the storm tightened its grip on the Great Lakes during the long night of November 8th and the early hours of November 9th, communication across the region began collapsing piece by piece. The blizzard had already buried cities in snow, railways had fallen silent, and roads had become impassable. But perhaps the most unsettling silence was the one spreading across the wireless networks that ships relied on to communicate with the outside world. During the early 20th century, wireless telegraphy was still a relatively new technology. Ships on the Great Lakes were increasingly equipped with radio transmitters that allowed operators to send Morse code messages across long distances. These messages travelled through the air as radio waves and could be received by coastal stations or by other ships nearby. For sailors working on the lakes, this technology had become an important lifeline. In calm weather, operators exchanged routine reports about position, cargo, and arrival times. When storms developed, those same radios allowed ships to warn each other about dangerous conditions or request assistance if something went wrong. During the White Hurricane, these wireless messages became the only thread connecting the ships trapped in the storm to the people waiting on shore. But the storm itself was slowly tearing that thread apart. The atmosphere above the lakes was filled with electrical activity created by the violent collision of air masses. Static crackled across radio frequencies as the storm churned through the clouds. The interference made it difficult for operators to hear incoming signals clearly. Even when a message was transmitted successfully, the receiving station might struggle to interpret the faint pulses of Morse code through the noise. At the same time, the physical conditions aboard the ships made communication harder with every passing hour. Wireless operators often worked in small radio rooms near the upper sections of the vessel. These spaces were not immune to the storm. Freezing spray coated the exterior walls. Ice formed around windows and door frames. The constant pounding of waves shook the entire structure. Operators had to remain focused despite the chaos around them. They leaned over their equipment, listening carefully through headphones for the faint signals of other ships calling through the storm. Each dot and dash of Morse code had to be recognized quickly before the static swallowed it. Some operators managed to send short updates. A few ships reported their positions early in the storm, describing heavy seas and violent winds. Others sent messages warning nearby vessels about the growing blizzard conditions on the lakes. But as the storm intensified, the number of messages began to decrease. One reason was simple exhaustion. Crew members throughout the ships were working constantly to keep their vessels afloat. Ice had to be broken from the decks. Cargo had to be secured. Engines required careful monitoring to maintain power against the waves. The wireless operator was often one of the few crew members not directly involved in those physical tasks. But even he faced challenges that made communication difficult. The ship's violent motion caused equipment to slide across tables or vibrate unpredictably. Electrical connections sometimes loosened under the constant shaking of the hull. And then there was the noise. The roar of the wind outside the ship was so loud that it vibrated through the metal walls. Waves slamming against the hull produced deep, booming sounds that echoed through the interior compartments. Listening for faint radio signals in that environment required intense concentration. Still, many operators continued trying. They tapped out messages describing the storm and requesting weather updates from shore stations. Some messages asked nearby ships about their position or condition. Occasionally, another operator answered. These brief exchanges provided small moments of reassurance during the storm. Knowing that another vessel was still afloat somewhere in the darkness gave crews a sense that they were not entirely alone. But as the hours passed, the radio traffic grew quieter. Ships that had sent messages earlier in the day stopped responding. Operators aboard nearby vessels attempted to call them repeatedly. They tapped out the ship names in Morse code and waited for an answering signal. Nothing came back. At first, many sailors assumed that the missing ships had simply lost their radio equipment to the storm. Ice build-up might have damaged the antenna. Electrical systems could have failed after repeated waves crashed across the deck. But there was another possibility no one wanted to say out loud. Some ships might no longer exist. During severe storms, a vessel can sink very quickly if the hull is breached, or if the ship capsizes under the force of large waves. In such situations, there may be no time to send a distress message. The crew might be struggling simply to survive the next wave. Even when a captain recognized that the ship was in serious danger, the circumstances might prevent a radio call from being made. The wireless operator could be injured, the equipment might be damaged, power might have failed entirely. In those moments, the storm erased the ship without leaving a trace of communication behind. For coastal wireless stations, the silence was deeply unsettling. Operators on shore continued listening for signals from ships across the lakes. Their equipment picked up occasional transmissions from vessels still battling the storm. But the list of ships that failed to report grew longer with every hour. Some shore stations attempted to broadcast general warnings across the radio frequencies, urging ships to seek shelter if possible. The messages travelled outward across the storm, but it was impossible to know which vessels were still able to receive them. Meanwhile, families waiting in port cities had no way of knowing what was happening. Many sailors working aboard Great Lakes freighters came from the same communities where the ships regularly docked. When a vessel was overdue, people noticed quickly. During ordinary delays, a ship might arrive several hours late because of rough weather or mechanical trouble. But during the White Hurricane, entire days began passing without word from some vessels. Relatives gathered at docks or near harbour offices hoping for news. Harbour officials could offer little information. Telegraph lines connecting many cities had been damaged by the storm, limiting the flow of reports between different ports. The wireless stations remained the only possible source of information, but the radios brought mostly silence. In a few rare cases, fragments of messages were received that seemed incomplete, or garbled by static. Operators tried to piece together the meaning, writing down the dots and dashes they could hear through the noise. Sometimes the fragments suggested that a ship was in serious trouble, but without the full message, no one could be certain. As the storm continued through the night, those partial signals and unanswered calls became haunting reminders of the ship still out on the lakes. Each silent radio frequency represented a vessel somewhere in the darkness, struggling against wind, waves, ice, and snow. And for some of those ships, the final messages they attempted to send would never reach the shore. As the storm slowly began to weaken during November 9th, the violence that had dominated the Great Lakes for nearly 2 full days finally started losing its strength. The wind, which had roared across the water with hurricane force, gradually began to drop. The blinding sheets of snow that had erased the horizon started thinning as the storm system drifted eastward. But the quiet that followed did not bring immediate relief. Instead, it revealed the scale of what had happened. For the ships that had survived the White Hurricane, the first hours after the storm passed were filled with exhaustion and disbelief. Crews who had spent the previous night fighting ice, waves, and wind finally saw the lake around them clearly again. The sky remained grey and cold, but the visibility returned slowly as the blizzard moved away. The surface of the lakes looked strange. Where there had once been enormous waves crashing through the storm, the water now moved in long, heavy swells that rolled across the lake like slow breathing. Floating pieces of ice and debris drifted through the water, carried along by the currents left behind by the storm. For the sailors still standing on the decks of their ships, survival felt almost unreal. Many of them had been awake for more than 30 hours. During the storm, there had been no time for rest. Every crew member had worked continuously, breaking ice, securing equipment, and helping the captain maintain control of the vessel. Now the work paused for the first time. Some sailors simply sat down wherever they were standing. Others leaned against railings or machinery, too tired to move immediately. The silence after the storm felt unusual because the constant roar of wind and crashing waves had filled every moment for so long. Only the low rumble of the ship's engines and the slow movement of water remained. The decks of surviving ships looked dramatically different from how they had appeared before the storm. Thick layers of ice still clung to railings, lifeboats, ladders, and cables. In some places, the frozen spray had formed shapes several inches thick. The ship itself looked as though it had been carved from ice rather than built from steel. Crew members began inspecting the damage. Many vessels had lost equipment during the storm. Lifeboats had been torn away by massive waves. Cargo hatches had been bent or damaged by the force of the water. Antennas and radio equipment were often twisted or coated with ice. In some cases, the ships had also suffered structural damage. Repeated impacts from the enormous waves had strained the hull plates. Rivets along the seams of the vessel had loosened slightly. Pumps were used to remove water that had entered cargo holds or lower compartments during the storm. But despite the damage, these ships were still afloat. For their crews, that fact alone felt remarkable. Captains quickly began attempting to re-establish communication with other vessels and shore stations. Wireless operators returned to their equipment and started sending messages across the calmer air. The first reports were simple. Ships announced that they had survived the storm and were continuing toward their destinations. They described heavy damage, dangerous ice accumulation, and extreme waves. Then the questions began. Operators called for the ships that had disappeared during the storm. They tapped out the names again and again, hoping for a response. Most of those calls received no reply. The surviving sailors gradually realized that many of their companions on the lakes had not been as fortunate. Still, the storm had not claimed every ship. Several vessels had managed to ride out the storm through careful navigation and relentless work by their crews. Some captains had kept their ships pointed directly into the wind for nearly 2 days, preventing the waves from striking the vessel broadside. Others had found brief shelter along shorelines, where the land reduced the height of the waves. The decisions made during the storm often determined whether a ship survived or disappeared. On some ships, crew members later recalled moments during the storm when they believed the vessel might sink. Waves had crashed across the decks with such force that it seemed impossible for the ship to recover. In those moments, the sailors simply continued doing their jobs, breaking ice, adjusting ropes, monitoring the engines. Every small action helped the ship endure the storm a little longer. When the wind finally weakened and the sky began clearing, those crews realized they had succeeded in surviving one of the most violent storms the lakes had ever produced. But survival came with its own emotional weight. As the surviving ships slowly made their way toward the nearest ports, sailors began seeing evidence of what the storm had done. Debris floated across parts of the lakes. Broken pieces of wood drifted among the waves. Cargo containers and fragments of equipment moved slowly with the currents. In some areas, lifeboats were found empty, carried far from the ships they once belonged to. Each discovery hinted at the fate of vessels that had disappeared during the storm. When the surviving ships finally reached harbour, the reception waiting for them was quiet and tense. Dock workers and harbour officials had been watching the lakes anxiously since the storm began. They knew that many ships had been caught in the blizzard. Each vessel that appeared through the cold grey air was greeted with a mixture of relief and concern. Crew members stepped onto solid ground for the first time in days. Some sailors were so exhausted that they struggled to walk steadily along the docks. Others stood silently looking back toward the lake, still processing the storm they had endured. News began spreading quickly through the port towns. Ships that had survived reported the violent conditions they had faced. Their stories described waves taller than houses, ice forming faster than it could be removed, and winds strong enough to push massive freighters sideways across the water. But alongside those stories came a growing list of ships that had not returned. Harbour officials began compiling records of which vessels had arrived safely and which were still missing. As the hours passed, the missing list continued growing longer. For the survivors, the realization was sobering. They had faced the same storm as the missing ships. The difference between survival and disaster often came down to small factors: timing, location, mechanical reliability, or the direction a captain had chosen during the worst moments of the storm. Some sailors would later say that luck had played a role as well. Standing on the quiet docks after the storm, the survivors knew they had witnessed something extraordinary. The White Hurricane had shown the full power of the Great Lakes in winter conditions, and while many ships had endured the storm, others had been lost beneath the freezing water, leaving the survivors to tell the story of what had happened out there. When the storm finally loosened its grip on the Great Lakes and the skies began to clear, the region entered a strange period of quiet reflection. The wind no longer roared across the water. The blizzard that had buried cities and harbours gradually faded into lighter snowfall. For the first time in days, the horizon became visible again. But the storm had not simply passed and left everything unchanged. The White Hurricane had altered the Great Lakes in ways that people would feel for years afterward. At first, the change appeared in the most immediate form: damage. Shorelines around the lakes were scattered with debris carried in by the storm. Broken timbers from docks lay tangled among frozen driftwood. Cargo fragments from wrecked ships washed onto beaches and rocky shores. In some places, lifeboats that had once belonged to freighters were found overturned along the coastline, far from where they had been launched. Communities along the lake spent days exploring the shoreline, trying to understand what the storm had left behind. Lighthouse keepers were often the first to report these discoveries. Many of them had remained at their posts throughout the storm, watching the blizzard from isolated towers overlooking the water. When the weather finally cleared, they walked along the nearby shorelines and noticed pieces of wreckage drifting in with the waves. These reports began spreading between towns. Harbour officials collected the information carefully. Each piece of wreckage offered clues about the ships that had vanished during the storm. Sometimes the name of a vessel could be identified from markings on a lifeboat or equipment fragment. These discoveries slowly confirmed what many people already feared. Several large ships had been lost entirely. The White Hurricane would eventually be recognised as one of the deadliest natural disasters in the history of the Great Lakes shipping industry. 12 ships were destroyed during the storm, and more than 200 sailors lost their lives. For communities along the lakes, those numbers were not just statistics. Many sailors working aboard Great Lakes freighters came from the very towns where the ships docked regularly. Families living in port cities like Detroit, Cleveland and Buffalo knew the vessels well. They had watched them arrive and depart countless times throughout the shipping season. Now some of those ships would never return. News of the losses spread slowly through the region. Communication systems were still recovering from the storm. Telegraph lines had to be repaired before reliable information could travel between cities again. But once the reports began arriving, the scale of the disaster became clear. Families gathered in harbour offices waiting for confirmation about ships that had been reported missing. Shipping companies attempted to contact surviving vessels to determine which crews had made it safely through the storm. For many people, the answers were heartbreaking. The storm had claimed entire crews in some cases, leaving no survivors to describe exactly what had happened during the final moments of those ships. Despite the tragedy, the surviving sailors carried important knowledge with them. When they reached port, investigators and shipping officials spoke with the captains and crew members who had endured the storm. These sailors described the extreme conditions they had faced: hurricane-force winds, towering waves, heavy icing, and blinding snow. Their stories revealed just how unusual the storm had been. Most Great Lakes storms, even severe ones, did not combine all of these dangers at the same time. The White Hurricane had done exactly that. The storm behaved like a powerful cyclone while also producing blizzard conditions and rapid freezing temperatures. The combination overwhelmed many vessels. These accounts led to important discussions about how ships could be better prepared for future storms. shipping companies began examining their safety procedures more carefully. One of the first topics discussed was weather forecasting. In 1913, meteorologists did not yet have the technology to track large storm systems with the accuracy we expect today. Weather reports depended on observations from scattered stations connected by telegraph lines. Forecasting offices could identify developing storms, but predicting their exact path and intensity was much more difficult. The White Hurricane exposed the limits of that system. Many ships had already left port before the full severity of the storm was understood. By the time stronger warnings were issued, the vessels were already far out on the lakes. After the disaster, efforts began to improve how storm warnings were delivered to ships. Signal flags used at harbours were re-evaluated to make sure they communicated weather threats more clearly. Wireless telegraph systems aboard ships became even more important as a way to send updates between vessels and shore stations. These communication improvements gradually strengthened the safety network across the lakes. Ship design also became a topic of discussion. The freighters lost during the storm had been strong steel vessels, but the conditions of the White Hurricane revealed how vulnerable ships could become when ice accumulated rapidly across their decks. The extra weight of ice could affect stability and make it harder for vessels to recover from powerful waves. Engineers began studying ways to improve ship structures and deck layouts to reduce ice buildup. Additional equipment for removing ice was also considered important. Crew members already carried axes and tools for breaking frozen spray from the decks, but the storm showed that faster and more effective methods might be necessary during extreme weather. Harbour infrastructure also changed in response to the disaster. Some breakwaters and docking facilities had suffered damage from the enormous waves pushed into the shoreline by the storm. Repairs and reinforcements were made in several ports to better protect ships seeking shelter during future storms. Meanwhile, meteorologists studied the storm carefully. Weather records collected during the event revealed just how unusual the atmospheric conditions had been. The storm had formed when multiple weather systems merged over the Great Lakes region, creating a powerful low-pressure cyclone fed by the temperature contrast between Arctic air and the relatively warm lake water. Modern meteorologists would later refer to the event as an extratropical cyclone with hurricane-force winds. Although similar storms have occurred in the Great Lakes region before and since, the White Hurricane of 1913 remains one of the most powerful inland storms ever recorded in North America. For sailors who worked the lakes afterward, the memory of the storm remained strong. Stories of the White Hurricane circulated through shipping crews for decades. Older sailors told younger crew members about the storm as a warning about the power of the lakes during late autumn. The phrase "November gales" took on even deeper meaning after the disaster. Sailors understood that the lakes could produce storms capable of rivaling ocean hurricanes, especially when cold Arctic air collided with warmer conditions lingering over the water. Despite these dangers, shipping on the Great Lakes continued. The lakes remained an essential transportation route for the industries and cities surrounding them. Cargo still moved between ports every year, and crews continued working aboard the freighters that crossed the inland seas. But the White Hurricane left behind a permanent reminder of how powerful those waters could become. Every sailor who stepped aboard a freighter during the late autumn months knew that the lakes had once unleashed a storm strong enough to bury cities in snow, silence railways, and sink massive ships. And that knowledge would shape how people respected the Great Lakes for generations to come. Long after the winds had faded and the waves had settled back into their normal rhythms, scientists and meteorologists began examining the storm with a different kind of curiosity. The people who lived through the White Hurricane had described it using the language available to them at the time. They spoke about winds that felt like ocean hurricanes, snow that erased entire landscapes, and waves so powerful that even the largest ships struggled to survive. But behind those experiences was a complex atmospheric event that scientists would spend years trying to understand. The storm had not been a tropical hurricane in the usual sense. Hurricanes form over warm ocean waters near the equator, drawing their energy from heat rising out of the sea. The Great Lakes sit far from those tropical regions and are surrounded by land that cools quickly during autumn. So the question became simple. How could a storm in the middle of North America produce winds that behaved so much like a hurricane? The answer begins with pressure. Air pressure is one of the most important factors controlling weather. The atmosphere is constantly adjusting itself as air moves from areas of higher pressure toward areas of lower pressure. When the difference between these pressures becomes large, the movement of air accelerates. That movement is what we experience as wind. During the early days of November 1913, meteorological records showed that an unusually deep low-pressure system had formed over the Great Lakes region. At the same time, strong high-pressure air masses were positioned both to the west and north of the lakes. This setup created an enormous pressure gradient. The pressure gradient is simply the difference in pressure between two areas. When that difference grows large, air begins moving faster in an attempt to balance the system. In the case of the White Hurricane, the pressure difference became extreme. Air rushed toward the low-pressure center from every direction, producing the violent winds that swept across the lakes. Some weather stations recorded gusts approaching hurricane strength. Modern analysis suggests that sustained winds across parts of the lakes reached around 70 miles per hour, with even stronger gusts. But the pressure gradient alone does not explain why the storm became so intense. Another major factor was the collision of air masses. During autumn, North America often experiences dramatic temperature contrast between north and south. Cold Arctic air begins moving down from Canada, while warmer air still lingers across the southern United States. When these two air masses meet, the boundary between them becomes a powerful zone of instability. Cold air is heavier and denser than warm air. When it pushes beneath warmer air, the warmer air is forced upward into the atmosphere. Rising air cools as it climbs, causing moisture to condense into clouds and precipitation. If the conditions are strong enough, this rising motion can feed the development of large storm systems. That is exactly what happened during the White Hurricane. Several separate low-pressure systems were already moving across the central United States. As they approached the Great Lakes, they began interacting with each other. Instead of remaining separate storms, they merged into a much larger and more powerful cyclone. Meteorologists sometimes refer to this process as cyclogenesis. Cyclogenesis simply means the development or strengthening of a cyclone, which is a rotating low-pressure weather system. As the storm deepened, the pressure at its centre dropped further. The lower the pressure fell, the stronger the surrounding winds became. The storm eventually formed a large rotating circulation over the Great Lakes. Wind moved counterclockwise around the low-pressure centre, which meant different parts of the lakes experienced winds from different directions. In some areas, the wind blew from the northwest, while in others it came from the west or north. This shifting wind direction created extremely chaotic wave patterns across the lakes. Normally, waves travel in relatively consistent directions depending on the wind, but when winds change direction during a storm, waves moving from different directions can collide with each other. The result is confused seas. Instead of long-rolling swells, the water becomes chaotic and unpredictable. Waves can rise steeply and break violently when they intersect with other waves moving at different angles. For ships navigating the lakes during the White Hurricane, these confused seas made steering far more dangerous. Another key factor in the storm was the temperature of the lakes themselves. Even though November is considered late autumn, the waters of the Great Lakes still hold warmth from the summer months. Water absorbs heat slowly and releases it slowly, meaning the lakes remain relatively warmer than the surrounding land as winter approaches. When cold Arctic air swept across the lakes during the storm, the temperature difference between the water and the air created powerful upward currents. Warm moisture rose from the surface of the lakes into the colder atmosphere above. This process fed energy into the storm system. Meteorologists today recognize this interaction as one of the drivers behind lake effect weather. When cold air moves over warmer lake water, it gathers moisture and heat. As that air moves inland, the moisture condenses and falls as heavy snow. During the White Hurricane, this process helped generate the intense snowfall that accompanied the storm. The combination of strong winds and heavy snow produced blizzard conditions across much of the Great Lakes region. Visibility dropped to near zero in many areas, making navigation extremely difficult for ships and dangerous for people travelling on land. The freezing temperatures introduced another layer of danger. When waves crashed across ships during the storm, water sprayed high into the air. Because the air temperature was well below freezing, that spray froze immediately upon landing on the vessel. This process is called freezing spray. Freezing spray can build thick layers of ice on ships within a short period of time. As the ice accumulates on railings, cables, and upper structures, it adds weight high above the ship's centre of gravity. This can make a vessel unstable. In severe cases, heavy ice accumulation can cause a ship to roll more easily when struck by waves. If enough ice builds up, the vessel may lose its ability to right itself after leaning to one side. Many of the ships caught in the White Hurricane experienced this exact problem. Finally, the size of the lakes themselves played a crucial role in the storm's power. Unlike smaller inland lakes, the Great Lakes offer enormous open surfaces where wind can travel uninterrupted for hundreds of kilometres. This distance, known as fetch, allows the wind to transfer energy into the water continuously. The longer the fetch, the larger the waves can grow. During the storm, the wind blew across some of the longest possible stretches of open water on the lakes. That allowed waves to build to extraordinary heights. When those waves struck ships already struggling with freezing spray and hurricane-force winds, the situation became extremely dangerous. Taken together, all of these factors created the perfect conditions for one of the most powerful storms ever recorded on the Great Lakes. A deep low-pressure system, a strong pressure gradient, colliding air masses, warm lake water feeding the atmosphere, freezing temperatures producing heavy ice, and enormous stretches of open water where the wind could build towering waves. Each element strengthened the others. The result was the White Hurricane, a storm that behaved like a powerful ocean cyclone even though it formed far from the sea. Understanding these scientific processes has helped meteorologists recognize similar storm patterns in later years. Modern forecasting technology allows scientists to detect developing systems earlier and warn ships and communities about the potential dangers. But the storm of 1913 occurred at a time when those tools did not yet exist, and because of that, the people who faced the White Hurricane experienced its full force without the benefit of modern prediction. Long after the winds stopped howling across the Great Lakes and the last broken pieces of wreckage drifted quietly toward the shoreline, the storm of November 1913 continued to attract attention from scientists. For the people who lived through it, the White Hurricane remained a memory filled with powerful images: ships vanishing into waves, cities buried beneath snow, and winds that seemed far stronger than anything normally seen so far inland. For meteorologists, the storm became something else as well. It became a puzzle. Weather scientists studying the event quickly realized that the storm did not behave like a typical system that moved through the Great Lakes during autumn. Storms in that region often bring strong winds and snowfall, especially during November when cold Arctic air begins interacting with warmer air lingering over the continent. But the White Hurricane had combined several extreme features at the same time. It was unusually powerful, it lasted longer than most storms, and it produced a combination of hurricane-force winds, blizzard conditions, and freezing spray that made it especially dangerous for ships. These unusual characteristics made the storm an important case study for meteorologists trying to understand how extreme weather can develop in the middle of a continent. One of the first reasons the storm continues to fascinate scientists is its rapid intensification. When meteorologists examine historical weather records from early November 1913, they see that the low-pressure system responsible for the storm deepened very quickly. In meteorological terms, this means the pressure at the centre of the storm dropped faster than normal. Rapid drops in pressure are often associated with strong storms. As pressure decreases in the centre of a system, the surrounding air rushes inward more quickly. That movement strengthens the winds circling the storm. In the case of the White Hurricane, the pressure gradient became extremely strong, which explains why the winds across the lakes reached such unusual speeds. But the pressure drop alone was not enough to create the full storm. Meteorologists studying the event noticed that the atmosphere over North America during those days contained an unusual arrangement of air masses. Cold Arctic air was moving southward at the same time that relatively warmer air was drifting north from the southern United States. This clash created a large zone of atmospheric instability. In meteorology, instability means that the air is prone to rising motion. Warm air rises more easily than cold air, and when it's forced upward by an advancing cold air mass, it can create powerful storm systems. The Great Lakes region often sits directly in the path of these clashes between cold and warm air. But in early November 1913, several separate storm systems were already travelling through the region. Instead of remaining isolated, they merged together as they approached the lakes. This merging process created a much larger and stronger storm. Meteorologists sometimes describe this kind of event as a storm merger or phasing, where multiple low-pressure systems combine into a single powerful cyclone. When this happens, the resulting storm can grow much stronger than the individual systems would have been on their own. That appears to be exactly what happened during the White Hurricane. Another feature that fascinates meteorologists is the storm structure. Although it was not a tropical hurricane, the storm behaved in some ways like one. The wind speeds were comparable to those seen in ocean hurricanes, and the circulation pattern of the storm produced long periods of sustained wind across the lakes. However, the storm also produced intense snowfall and freezing temperatures, which are not typical of tropical hurricanes. This unusual combination places the White Hurricane into a category that meteorologists now call an extratropical cyclone. Extratropical cyclones are large storm systems that form outside the tropics. They're powered not by warm ocean water, but by temperature contrast between different air masses. These storms can sometimes become extremely powerful, especially when the temperature differences are large, and when strong upper-level winds in the atmosphere help intensify the system. In the case of the White Hurricane, scientists believe that strong winds high in the atmosphere played an important role. These upper-level winds helped remove air from the top of the storm system, allowing more air to rise from below. This process deepened the low-pressure centre and strengthened the overall circulation of the storm. Modern meteorology uses satellites and advanced computer models to observe these processes in detail. But in 1913, none of those tools existed. Meteorologists at the time had only surface weather observations collected from stations scattered across the continent. These observations were transmitted by telegraph and plotted by hand onto weather maps. This meant that forecasters could see that a storm was developing, but they could not observe its full structure or track its intensification in real time. Because of this limitation, the White Hurricane arrived with far less warning than a similar storm would today. For modern meteorologists, this historical gap makes the storm even more interesting. Scientists now reconstruct the storm using archived weather records, ship logs, and atmospheric data from the time. By feeding those observations into modern computer models, they can simulate how the storm likely developed and evolved over the lakes. These reconstructions help scientists understand how similar storms might form in the future. The Great Lakes region remains vulnerable to powerful autumn storms even today. The same ingredients that created the White Hurricane still exist: large bodies of relatively warm water, cold Arctic air masses moving southward, and strong atmospheric circulation patterns. While modern forecasting systems provide far better warnings, the fundamental meteorological processes have not changed. Another reason the storm fascinates scientists is its impact on lake effect weather. The intense snowfall produced during the storm demonstrated how strongly the lakes can influence regional weather. When cold air moves across the relatively warm lake surfaces, moisture rises rapidly into the atmosphere. This moisture then falls as snow when the air cools again over land. Lake effect snowstorms remain a major feature of winter weather around the Great Lakes today. Cities such as Buffalo, Cleveland, and parts of Michigan regularly experience heavy snowfall because of this process. The White Hurricane showed how extreme lake effect conditions can become when combined with a large storm system. Finally, the storm continues to interest meteorologists because of its role in improving weather forecasting. Disasters often push scientists to improve their understanding of natural events. After the White Hurricane, greater attention was given to tracking storm development across the continent. Over the following decades, meteorological technology advanced significantly. Weather balloons began providing information about the upper atmosphere. Radar systems allowed scientists to observe precipitation patterns in real time. Eventually, weather satellites offered a global view of storm systems moving across the planet. Today, meteorologists can track developing storms days in advance and warn communities about potential dangers. But the storm of 1913 remains a reminder of how powerful weather systems can become when the right atmospheric ingredients come together. More than a century later, the White Hurricane is still studied as one of the most dramatic examples of inland storm development in North American history. And every autumn, when cold winds begin moving across the Great Lakes again, meteorologists remember the storm that once turned those inland seas into a frozen hurricane. When the storm finally passed and the skies over the Great Lakes cleared, the silence that followed felt heavy. The wind no longer screamed across the water. The snow that had once raced sideways through the air settled slowly onto frozen docks and quiet streets. The lakes themselves, which had roared like an ocean during the storm, now moved with a slow, uneasy rhythm. But as the days passed and ships began reaching port again, the reality of the disaster became impossible to ignore. Not every vessel had survived the White Hurricane. In the days following the storm, harbour officers across the Great Lakes began compiling lists. These lists recorded which ships had safely reached port and which ones were still missing. At first there was hope that some vessels had simply taken shelter in distant harbours or been delayed by damaged communication lines. But gradually the pattern became clear. 12 ships had been lost. The names of those ships would become part of Great Lakes history. Vessels that had once moved quietly across the inland seas carrying iron ore, coal, grain and other cargo. Ships that had docked countless times in the cities surrounding the lakes. Ships whose crews included men who had worked the lakes for years. Among them were large steel freighters like the Charles S. Price, the Regina and the Wexford. These vessels had been strong ships designed for lake travel, yet the storm had overwhelmed them. Along with the ships, more than 200 sailors were lost. For the communities around the lakes, these losses were deeply personal. Many of the sailors came from towns that depended on shipping as a major part of their economy. Families had watched the freighters leave harbour only days earlier, expecting them to return as they always had. Instead, the storm had erased them. News of the disaster spread slowly across the region. Telegraph lines had been damaged during the storm, and communication between cities took time to recover. But once the reports began circulating, the scale of the tragedy became widely known. Newspapers across the United States and Canada printed long lists of the missing ships. Readers followed the updates carefully as search efforts began across the lakes. Tugboats and surviving freighters scanned the water for wreckage. Lighthouse keepers watched the shorelines for debris washing in with the waves. Gradually, fragments of the lost ships began appearing. Pieces of wood drifted onto beaches. Lifeboats were discovered overturned along remote stretches of shoreline. Cargo containers floated slowly through the water, carried by the currents. Each discovery confirmed what many people had already feared. The ships had sunk during the storm. In some cases, wreckage was found far from the locations where the vessels had last been reported. The violent waves and strong currents had scattered debris across wide areas of the lakes. One of the most haunting discoveries occurred when the hull of the Charles S. Price was found floating upside down on Lake Huron. The ship had been completely overturned. Search crews eventually located several bodies inside the hull, confirming that the vessel had capsized during the storm. The sight of the enormous freighter floating upside down became one of the most powerful symbols of the White Hurricane's destruction. Other ships simply disappeared without leaving clear evidence behind. The waters of the Great Lakes are deep in many places, and wrecked vessels can sink quickly beneath the surface. Some ships that vanished during the storm were not located until decades later, when underwater exploration technology improved. For the families of the sailors, the waiting was often the hardest part. Without immediate confirmation, many relatives spent days hoping that their loved ones had somehow survived. Harbour officers received visitors constantly as families asked whether any new ships had arrived or whether additional wreckage had been identified. Eventually, the lists of survivors stopped growing. Memorial services were held in towns across the Great Lakes region. Churches filled with people mourning sailors who had worked the lakes for years. Shipping companies held ceremonies to honour the crews lost during the storm. The disaster became one of the deadliest maritime events in the history of the Great Lakes. Yet alongside the grief, the storm also left behind a sense of respect for the sailors who had faced it. Working aboard Great Lakes freighters had never been an easy profession. Sailors spent long months away from home during the shipping season, moving cargo across vast waters that could change quickly from calm to dangerous. The storm of 1913 demonstrated just how demanding that work could become. The men aboard those ships had continued their duties even as the wind reached hurricane strength and the waves grew higher than houses. They broke ice from the decks, maintained the engines, and steered their vessels through blinding snow in an effort to survive. Their efforts represented the quiet determination that had defined Great Lakes sailors for generations. Over the years, the memory of the lost ships became part of the region's maritime heritage. Historical societies collected photographs, ship logs, and personal stories connected to the disaster. Museums along the lakes began displaying artifacts recovered from wreck sites and shoreline debris. These collections helped preserve the story of the White Hurricane for future generations. Underwater exploration in later decades also revealed more details about the wrecks. Advances in sonar technology allowed researchers to locate several of the ships resting on the lake beds. Divers eventually explored some of these wreck sites, documenting the remains of vessels that had vanished during the storm. In the cold, fresh water of the Great Lakes, shipwrecks can remain remarkably well preserved. Steel hulls that sank during the White Hurricane still rest on the lake floor more than a century later. In some cases, equipment and cargo remain in place exactly as they were when the ships disappeared beneath the waves. These underwater sites serve as quiet memorials to the sailors who lost their lives. Today, the White Hurricane remains one of the most significant events in Great Lakes maritime history. Each year, historians and maritime organisations remember the disaster through articles, documentaries and commemorations. The story continues to be shared not only because of the storm's power, but because of the people who faced it. Every ship that sailed the lakes during that storm carried a crew of men working together in difficult conditions. Their work supported the industries and communities that grew around the Great Lakes. Remembering the storm also means remembering those sailors. Their names remain recorded in maritime archives and memorials across the region, and their story remains a reminder of the risks faced by the people who navigated the vast inland seas of North America long before modern forecasting and communication made such journeys safer. When the storm finally moved away from the Great Lakes and the skies began to open again, the region entered a strange kind of calm. The wind that had screamed across the water for days slowly faded into a quiet breeze. The snow stopped racing sideways through the air and instead settled gently over the frozen landscape. For the first time since the storm began, the lakes looked still. The enormous waves that had towered across the water during the White Hurricane gradually flattened into long rolling swells. These swells moved slowly across the lake surface, like the last breath of a storm that had already spent its strength. But the quiet that followed was not the same calm that had existed before the storm. Something had changed. Along the shorelines, the signs of the storm were everywhere. Harbours that had once been filled with activity were now coated with thick layers of ice. Dock posts looked like frozen pillars, their shapes altered by the spray that had hardened around them. Boats tied along the piers appeared trapped in shells of ice, that had formed over their railings and decks. The landscape itself looked reshaped. Trees near the water leaned under the weight of frozen spray that clung to every branch. Fences and street signs carried thick coatings of ice and snow. Streets in the city surrounding the lakes were still buried beneath deep drifts that crews were slowly working to clear. But the most powerful changes were out on the water. The Great Lakes had always been busy highways for ships moving between cities and ports. Freighters carried iron ore from the mines of Minnesota and Michigan to steel mills farther south. Grain moved eastward toward markets and ports along the Atlantic. Coal, machinery and other cargo travelled constantly across the inland seas. Now, after the storm, that movement had paused. Ships that had survived the White Hurricane reached port slowly in the days that followed. Many arrived coated in ice, their decks damaged by the storm. Crews looked exhausted after fighting the wind and waves for nearly 2 days without rest. Harbour workers helped guide the battered vessels into dock. When the ships tied up, sailors stepped onto land with the careful movements of men who had spent too long balancing on a moving deck. For many of them, the quiet of the harbour felt almost unfamiliar after the constant roar of the storm. They looked back toward the lake, knowing that not every ship had made the journey. The water itself gave few signs of the disaster beneath its surface. From the shore, the lakes looked calm again. A person standing along the beach might see only gentle waves sliding onto the sand. The horizon stretched quietly across the distance, just as it had before the storm began. Yet somewhere beneath that calm surface rested the wrecks of ships lost during the White Hurricane. The Great Lakes are deep in many places, and their cold fresh water preserves shipwrecks remarkably well. When a vessel sinks beneath the surface, it often remains there for decades, sometimes centuries, slowly becoming part of the underwater landscape. The ships lost during the storm settled quietly on the lake beds. Above them, the water continued moving as it always had. Waves rolled across the surface, ice formed and melted with the passing seasons. New ships travelled the same routes that the lost vessels had once followed. But the memory of the storm remained. In the towns and cities around the lakes, people spoke about the White Hurricane for years afterward. Sailors who had survived the storm told their stories to younger crew members boarding ships for the first time. Harbour workers remembered the days when the wind had roared across the water with hurricane force. The storm became part of the region's history. Meteorologists continued studying it, trying to understand how such a powerful system had formed so quickly. Engineers examined ship designs and safety procedures to reduce the risks faced by sailors during future storms. Gradually, the Great Lakes returned to their usual rhythms. Shipping resumed as damaged vessels were repaired and the surviving freighters returned to service. Cargo once again moved steadily between the ports scattered across the region. Dock workers returned to their routines of loading and unloading ships along the harbours. Life around the lakes continued, but the storm had left behind something deeper than damaged ships and frozen harbours. It had reminded everyone who lived and worked near the Great Lakes that these waters were not simply quiet inland lakes. They were vast, powerful bodies of water, capable of producing storms that rival those of the open ocean. The phrase November gales gained a deeper meaning after 1913. Sailors understood that late autumn on the lakes could bring sudden and violent weather. Even experienced captains approached the season with renewed caution. And yet, despite that respect, ships continued sailing. The Great Lakes remained an essential part of the region's economy and culture. Communities depended on the trade routes that crossed those waters. Each year, as winter approached, crews once again prepared their vessels for the final voyages before the lakes froze. The memory of the White Hurricane travelled with them. Sailors boarding freighters during late autumn knew that more than a century earlier, a storm had turned those inland seas into something resembling a frozen ocean hurricane. They knew that ships had vanished beneath towering waves. They knew that entire crews had been lost. And they also knew that the lakes, quiet and calm on many days, still held the power to produce such storms again. So the story of the White Hurricane remained part of the identity of the Great Lakes, not only as a tragedy, but as a reminder of the relationship between people and the powerful natural forces that shape the world around them. And now, wherever you are listening from tonight, perhaps far from the cold waters of those northern lakes, the story of that storm becomes just another moment carried quietly through time. Somewhere along the shores of Lake Huron or Lake Superior, the water moves slowly under the evening sky. Waves slide gently onto the beaches. Ships pass across the horizon just as they have for generations. The lakes look calm, almost peaceful. Yet hidden within that calm is the memory of a storm that once froze the air, buried cities in snow, and turned the inland seas into a white hurricane.